Hey guys, Chris Streaming Code. Thanks for tuning in. Today we're going to be making a space shooter in JavaScript. So let's dive on in. Alright, so let's first draw up kind of what we're going to be working on today. So, a little bit much larger. Okay, so I'm going to be making a space shooter. So I've probably seen games like these before. Okay, so we're going to have our screen here. And so when you, with 2D space shooters, they can either come from the side, so your ship's over here, and you're shooting this way, and bad guys are coming this way, or you could come from the bottom, and that's what we're going to do today. So it's going to be like top down. So there's our ship. We shoot bullets this way. We have various enemies coming this way, and we'll start out just making them if they hit us. We take damage. Maybe later we'll make them shoot. And we'll also have some power-ups. So maybe we'll have like a health power-up. And why don't we do like a, I don't know, some kind of rapid fire power-up that increases our rate of fire. We can always add more of those later. And then we'll have a score here. And then we'll also have a health bar. So maybe we'll say we have like, I don't know, 4 health. We can always change that up later too. So, and then basically as we go, we're going to stay put, but we'll kind of have a background that looks like it's moving. So it looks like we're moving forward because the background will be coming backwards. So yeah, and then just like we did with Pong yesterday, we'll go ahead and we'll have a start screen. Space shooter, just have a start button. When we hit that, we go to the game, and once we die, we'll say game over, and we'll like show like a final score, right? Final score. And then we'll have a play again button, which will also send you back to the game. Right? So let's just go ahead. We'll kind of mark out what we're going to have, what we're going to build. So we're going to have the button, which moves us, and then other than that, we just need to render it. Just gotta get everything rendered. We have our lives. We have enemies. We have the ability for us to shoot. We're going to move back and forth. And why don't we go ahead, we'll make it so we can move a little bit forward and back, not like all the way forward, but maybe like halfway or so. And then we have the bullets. We'll have power-ups. We'll have the score. We'll have the background. And here we'll have the button again, and we'll show the final score. Okay, so let's start out. We'll go ahead and we'll just whip up a couple quick graphics in Photoshop for it. We won't spend too much time. I'm definitely not an artist. If you don't want to try to create something, you can also go out hunting and find all sorts of free graphics out there to use, like ones that are actually like the author has actually said, this is free for you to use in your game. Go for it. Have fun. Don't like steal people's graphics. That's not cool. Okay, so let's see. I'm just going to kind of use some shapes, I think, to do the stuff. So let's see. We'll make a bullet, and I'll go ahead. Some of these are going to end up real small, but I can make them big just to be able to make them easier, and then we can kind of shrink them down once we're happy with them. Okay. So we got something like that, and I want to grab the every time a new version of Photoshop comes out, they've rearranged everything again. We want the okay, there we go. Okay, so that'll be kind of our bullet. And then easy way in Photoshop to colorize things is to do a color overlay. And let's go kind of yellow. Or maybe, actually, you know what? Instead of bullet, let me do a laser. So, let me ditch that. Let's just make it a laser instead. Something like that. We'll go through boundary options, color overlay, color, kind of nice lasery kind of yellow green. Yeah, sure, something like that. And two, when you're in the kind of early prototyping stages, it's okay to, in fact, probably even encouraged to not spend too much time on the graphics, because you can always swap out the graphics again. As long as they kind of match the technical requirements of what you're doing, you can build them up without spending tons of time. A little too wide. There we go. Okay, I'm gonna make sure I label each thing, because we're going to use Photoshop's ability to just export all the layers as individual images. I'm just going to show that over there, and I'll name it PNG. Okay, so there's that. Let's make a quick heart for the health. Start out on the two circles. Duplicate that one so they're the same size. Push those together. Let's go with a triangle. Tool to flip it around. Just kind of meet up here. Pen tool. There's a, what do they call that? The convert point tool. Sure. Okay. I've probably done these in Illustrator. Faster. Pen tools in Illustrator. Okay. Actually, go ahead and delete that point. Shortcut for this guy. That point. Up. Where does union now in Photoshop? No, I have to stitch the layers down. No. Alright, squeeze this in a bit. blending option, color overlay. Overlay. Blend, do a gradient. Color, maybe. Rotate it that way. And let's give it a stroke. Big stroke. Maybe. It to, alright, we're just going to do this actually. No, it's still going up the stroke. Alright, let's do undo, copy, blending options. Copy layer style, let's go. Content down, rasterize it, then I will there we go. Alright, good enough. Kind of ugly, good enough. This is a programming, not a creating graphic stream. Okay, oh, let's shrink her down. And now that stroke is way too strong. So let's just drop that stroke down a bit. Make it not black. We'll make it a dark gray instead, so it won't be quite as strong. Alright, good enough. So we'll have like 4 of those. Okay, so there's the heart. Okay, let's, for the ship and enemies, we're going to keep them really simple. We're going to have the attack of the square things for now. So there's our enemy. And then for our ship, we'll do something. I'll just keep it nice and simple for now. Rotation. Lateral. Rotation. Actually, rotation. We'll just drag this point over. Touch. Nope. Move. Okay. Now drag this one in. Maybe just a little back. Okay. Now copy this guy. Go to image, edit, transform, select, rotate, split. There it is. Frontal. And we'll just pop that sucker on there. A little bit wide, so I'll shrink it down a bit that way. There we go. That's not terrible. Alright, now we will mush it all into one, rasterize it, doop. And then we'll do blending option, color overlay, go gray. We're gonna have a white, or oops, I accidentally grabbed the square. Undo, not this guy. New.png. Back with Control E, blending option, color overlay. Okay, not too bad. Let's shrink it down a bit. Come on there. And let's, yeah, that'll be fine. Okay, so got that. Let's do a quick health power up. over one another. Take that. Okay. Stroke. Just fill that. And we're going to merge those together. Okay, so those are how power up, and that's probably a little too big, so let's shrink it down just a smidgen. About there, maybe. Okay, let's do a rapid fire power up. So maybe since we're doing lasers, maybe like a battery, like supercharge your laser shooting device and pop the battery. We'll make it like a AA battery. Okay, and for this one, let's go ahead. Okay. Go ahead. This one might be just a solid color, so let's go ahead, push it down to raster. And then we will do. Just kind of use the fill tool, I think. All right. Do kind of a silvery color. Fill. And then do, actually, we'll do that for the end. We'll do Control A, kind of get a hold of it, so when I draw with my brush, I'll only draw inside there. A bigger brush with the square key, and I'm just going to do a line. Switch the hardness to maximum hardness. Shrink it down a bit. I want to get right below that top part. There we go. And that's a little too thick, I think. Down. Good. Same on the bottom. Just a little bit. There we go. And fill, and we'll make it yellow. Or no. Yeah, we'll do yellow. We'll do a white light bolt. So, we go lightning bolt. We'll just do two triangles. One triangle. Let's do the hitchy there. Make this straight up and down. Whoop. I don't know what I did. That happened. Oh. No. Copy the triangle. There we go. Copy. Control V, so I pasted it in place so there's two of them stacked up. Flip one of them both directions. Edit, transform, vertical. I just did that. Transform. Horizontal first. Image. Transform. Vertical. There we go. And smash them together halfway through. Switch that up so the double line goes away. Together, blending. No, look at this is stroke growth. It's going to kind of not pop very well on top of the that yellow. Okay, and shrink it down so we can get fit. Two. Alright, that stroke is now too strong. Two. Down. Go plenty. Up just a bit. And on here, I keep squishing down my layers just because we're doing these real quick. If you were doing this real, you would not want to squish everything because you want to be able to come back and tweak it. But these are all just kind of real quick, one-time use things. So let's kind of squish couple other things. Battery.png. Flip it on and off to make sure that we're changing what we think we're changing. Ship.png. Heart user. Okay. This is of course just text. And in the last string, we created the buttons, like just with code. This time, let's just go ahead and make some image or some button images since we're using images anyway. So might as well. So color overlay. Well, we'll make these blue because I like blue, and we'll give them a stroke. Let's see. We'll use a space back. We'll make a space background. We'll use it on all three. So if this is popping up of a space background, let's give it light stroke. And this is about the real size of the button, so we'll leave it like that. Cancel. And for this one, I actually won't. Let's get it to the top, and let's actually pop it into a group. And this one will be button.png. So we'll have that. And then in the same group, we're going to have start. We'll make the color white. Whoops. Start. Drag it in the center. So both of these will keep a line up here. Okay, actually, let's switch our text to be all caps. We'll leave it like that. And we will, yeah, we can't have the corner in Photoshop like this. Try 80, maybe 10. That's not too bad. So, yeah, we'll leave it like that. That's good, I think. And here we'll pop in a black background on the whole page so we can kind of see how stuff will look popping off of it. Actually, no, that won't actually be our background because that'll be too big. We're going to make our game like yesterday. We'll make our game. Stuff pops pretty well. Oh, except the battery. The battery is stroke. Blending. Stroke. Light stroke. Too much of a light stroke. This one could go 20. Not amazing, but not bad. What I hit to do that. Okay. You know what? Maybe hitting the tablet or the locking tablet in my lap. Okay. This is start button.png. Okay. And then we'll duplicate that, and this will be the play again button.png. And we'll drag the whole group over. Stop that Photoshop. And the whole group. There we go. And play again. And either make the button wider or drop the text size. I think we'll drop the text size. Good enough. Okay. I think let's look back at our what we have. We got that and that. We got the laser bullet. We got the enemy. Where's just text? We got the button. Okay. We just need a background now. So for background, we like that Photoshop. Not that. Block it. Okay, and so we're making it on a 800 by 600. Actually, we'll make the background. So let's export these guys first. So we're going to go to File. Where is it? Export. I'm looking for generated image asset. That's the one. I do not like to use your crowd. Okay, we'll go ahead and hold it for this. So this is Space Shooter. Alright, so we'll make one asset. And so this is, let's call it asset. Alright, now we'll go Generate image assets. Okay, should be good now. Checking sure. So if you use that image asset, it should yeah, there we go. It'll export a anything you label that's like got a file name type name. It'll export as an individual thing, which is kind of handy when you're doing this. Good. It has a transparent background. All right. Good enough. And the cool thing is now too, if I like change one, it'll update it for me. I just have to go grab it. It's real handy if I'm doing stuff with like Unity or something. I can kind of just add assets that way because I'll just change it or make a new one here and then save it and it shows up in Unity. Okay, and let's now make the space background. So this space background, so one screen is going to be 800 by 600, but we're going to have it scroll down. So we want it to be taller than our 600, taller than our height. So we'll go ahead and we'll just double that. So we'll do 800 wide still, and we'll do 1200 tall. All right, how are we going to make our space background? So we'll start by filling it with that. Then let's try maybe a noise filter. We'll do monochromatic. Sorry. If you look at like actual space-based photos, it's like real starry because you don't have the atmosphere or anything blocking it. Next, and you know what? I think we'll just kind of go low tempo, but that's random dots now. Okay. Then I'm going to do on that, try to copy the blur a bit. Maybe motion blur. I'm not sure when blur does this. Oh, this background. We do it okay. Now, check the motion blur. Blur. Motion blur. And do a motion blur in the other direction. Blur, motion blur. And do the Gaussian blur, I guess. Blur, blur. Okay, and then just do a blend. And we'll do a outer glow. Just a little bit. Just to kind of make it glow a little. All right, good enough. And again, this would just be kind of a prototype, and you can always, this would be good enough to build the game, and then, or at least start building the game, and then you can always get another one brought in, hopefully by a proper developer, someone with more artistic skills than me, which are very little. Okay, so space shooter. All right, so we'll save this background as a PNG. Okay, now let's actually go. We're going to move those files a bit. First, we'll go ahead, just like always, I'm going to use, I'm just going to clone down a copy of basic web template. If you don't know Git and you want to use this, you can just do background mode, or you can use GitHub Desktop, or you can do like me, and I'm just going to use the command line because that's what I'm used to, and it's fast. And this is actually, so this one, so most of our games, the code repo has actually been right at the level. This one, since I have assets here, I'm actually going to put this inside of here. Git clone, then we'll call this code. So there'll be a code folder inside our Space Shooter folder. There we go. And now I'm going to copy all of our assets that we're actually going to use into the game into the public folder. There we go. And actually, we'll put those inside the images folder. Our index and our HTML and CSS are in this folder too. Drag them. Okay, there we go. So that's good enough for the coloring time. So let's go ahead and dive into the code. So go ahead, we'll open up a new code project. So Space Shooter, and in this case we want to open up, you could open up the top level. I like to just do the code window. This window. All right. Oh, hey, Screen Marker, thanks for joining. Yeah, C is interesting. I started out doing C and C++, and yeah, it's a bit rough. Pointers are no joke. I do not miss using those. Okay. All right. So let's we'll go ahead. So if you're using my kind of starter repo, you can ignore most of it here and just worry about the index HTML, CSS, and JavaScript files. Okay, so let's start out just like yesterday with Pong. The only real HTML we need is a canvas. So this is where we're going to draw all of our JavaScript, all of our game to. And then just like yesterday too, I'm going to go ahead and run npm install, and I'll get all of our dependencies that the build pipeline for this project uses installed. Okay, and then we're going to run npm run dev. That's going to get our build pipeline going. And then, so we're listening on port 8000 now, so we can go to our browser, go to port 8000, hit F12 to bring up the dev tools, or you can right-click and select on it. And so we can see we have our canvas here, so that's good. Something I've been forgetting to do that we'll start doing. We'll pop in a title so we can see. So this is our Space Shooter. And we can see now our title right up there. Okay, so we have our canvas there. It's white on white, so we can't actually see it. Let's pop into our canvas, our width and our height. So we're going to do 800 by 600. That's a 4:3 resolution. So we could go, actually, why don't we do a more modern resolution? No one does 4:3 anymore. So we'll do a 1610 resolution. So if we wanted to stick with 800 wide, then that's just 2 divided by 1600, so we can just do 2 divided. Oh, that's not 2, that's 5. I knew the answer, and it confused me. None of those numbers were right. We want 500. I don't know how to use a calculator, apparently. All right, so we'll stick with an 800 by 500. So a little shorter than 4:3. So that's kind of our modern browser size. So we'll go with that. And then let's go ahead just to kind of focus on the game. We'll hit the plus sign, inspect your style sheet, so you can kind of type out and fiddle with things directly all at once in real time, which is always fun. So we'll do a black background for the body, a white background for the canvas. We're going to position it absolutely. So top 50%, left 50%, and that puts the top left corner of our canvas smack in the middle of the screen. Then we'll do a transform, which transforms is all kinds of transforms. And we'll specify translate, which is just our fancy word for move. So there we go, smack dab in the middle. So I'm just going to copy paste that into my CSS because if I refresh the browser, this thing goes away. But now that I put it in my CSS, it's still here. So yay. yay. Now we're set to go start coding. So go ahead. So first thing, we'll get a hold of the canvas itself. Canvas query selector canvas, and then we're going to get a hold of the context, which is what we use to draw it. It's called the rendering context, and we're going to do a 2D context as opposed to like WebGL or something. Okay, and then we'll also go ahead and we're going to destruct out the width and height from the canvas because we're going to use those for a bunch of things. Okay, so now let's go ahead. We'll just start at the beginning. So we'll start with our start screen here. So we're going to render it. So we're going to have our background. So let's go ahead and get that in first. So to load images, we have to, there's a couple ways to do it. The easiest way, I think, to do it is just to create an image element. Create element. And then we're going to set the source of that to be the path to our image, which in this case is public images background.png. So I'm just kind of following the folder path, so public images background.png. And then, so I'm going to go ahead, just temporarily, I'm going to do document.appendChild, or document.body.appendChild background. I'm going to just throw it on the page just so you can kind of see. So see, it loads up. But one of the tricky parts is it takes it a minute to load up because loading happens asynchronously, which means it doesn't like, it's like, so here's where I basically tell it to load, but that doesn't mean that by this point it's loaded because it's happening asynchronously. It's happening on its time, as opposed to synchronous code, which does happen. Which, so what we do to track when an image is loaded, because we want to make sure it's loaded before we try to use it, bad things will happen. We can do background.add load or add event listener load, and this basically fires when we're loaded. So watch, I'll just kind of illustrate this. Image starting load. Log image loaded. Log after image load. And now watch what happens. So normally you might think it would go 1, 2, 3, but it's actually going to do this one and then this one and then sometime later that one. And that sometime later is real quick, but it's still not instant. In programming times, it takes a while. But here at this point, then we know that the image is loaded and that we're ready to use it. So we'll go ahead and let's get a little fancy with this. We're going to use async and await, which there's a couple different ways you can write async code in JavaScript. Async and await uses what are called promises, but they're kind of hidden. Like you see, you'd use promises directly. You'd like actually say like promise.create, and you do still sometimes do that, but await and async makes that much nicer. Then what we're going to do here is we're going to make a new function called load image. And it's going to be async. So putting async at the start of the function is basically telling the program telling JavaScript that this is an async function. It won't finish right away. So we'll go ahead and we'll put image path in here. We're going to move this stuff. We don't need to append that anymore. We're going to move this stuff in here. We're going to generify this just so we can use it for all of our images. So we create the image. We then do this. And this is actually going to be one of those cases where we will use promise directly. We're going to actually, from here, return a new promise. And how a promise looks is it's basically so you do new promise, and then you have a resolve and a reject here. And then it has a function. And then when you're ready, when you're done, you call resolve if it finished successfully. Otherwise, you call reject, which is an error. So we'll go ahead and we'll add another event listener for error. An error would fire off if we have an error. So we'll just and then you put what you want to return in here. So if it works, we're going to send back an image. If it doesn't work, we're going to spit out the error. And then we're just going to add a catch here, which will basically let us respond to the error. And we're not going to do a bunch of error handling. We'll just do this. So if we do get an error, we know. So what we have going on here then, so we create an image, we set the source, which starts at loading. Then we have an event listener for load, which will fire when the load is actually finished. And then we have another for error when if we get an error. Hopefully we never get in here, but we might. And we'll go ahead to let's actually pull out our handlers into their own functions or into their own variables. And we'll do load handler. And we'll pull this one out to here. And the reason I wanted to do that is because to clean up and not keep around event listeners we don't need anymore, we're going to remove both the load and error event listener. And to do that, we need to have a reference to those functions in a variable or something. Because you have to pass in that function you're trying to remove, it won't remove anything. Okay, so there we go. And now let's go ahead and we'll pull this whole load image into its own function because it's getting kind of cluttered. And splitting up your code in nice, easy to read chunks is a handy way to keep organized. And we'll just export default load image. So we export the image here. Let me go up here, import load image from load image file. Now we can use it here. So now we'll say background equals. Now the trick here is we use the keyword await, and that's paired with async. And so what this will do, unlike before where I showed you that like the code isn't running in the right order, await actually forces it to wait, so it will still load in the order we expect. So this will be public images background.png. Okay. And now we'll have access to we should have access to our background if it loaded right. So there we go. So we're all set. We have it. It's now loaded, and we're good to go. So now that we have it loaded, let's go ahead and we'll draw it onto our canvas. So to draw images onto our canvas, we use context.drawImage, one of the few canvas functions that actually kind of are obvious. A lot of them aren't. Okay, and then we'll just do 0, 0. And technically our space is taller, so it's going to get chopped off, but that's okay. We'll leave it like that. Unknown type. Okay, so this is right here is just my my IDE doesn't realize that load image is returning an image. So what I can do to help it out is I can go here and I can do promise. See how it says promise return unknown? I'm going to do promise image. And now my IDE should magically know that that is an image and not be so angry. Oh, not image element, right? HTML image element. There we go. There we go. See, now it knows what I'm talking about and it can keep helping me. So when you get those kind of squiggly lines, if you add a comment to kind of help your IDE out, it can be helpful because then your IDE can help you out in return. Okay, so we got that. So if we refresh our page, now hopefully we have an image. Yay. Okay. Okay. So we got a background drawing. Let's go ahead now. We'll draw just some text that says space shooter. Now we are title graphic. And of course, most of it, not even most, I would say almost all the time in like a real game, you'd want to have an actual graphic for this, but we'll just go with this manual way so we can play with manual stuff too. So we're going to set the fill style. We'll do the fill style to white. Actually, when we do the fill style to blue, we'll use this blue because I like it. And we'll set the stroke style to white. And we'll set the line width, which is how thick the stroke is, to maybe 4. And we'll set the font to maybe, let's see, we did like 120 on Pong, but Pong's a lot shorter than Space Shooter. So let's go maybe, I don't know, let's see if 60 will fit on one thing. 60 pixels, we'll do bold, 60 pixels. Let's go Arial Helvetica Sans Stack. Okay, so we got Space Shooter. And let's go ahead, we'll do a text baseline of top and a text align of center. That way, when we do our X now, because we did text line center, the X specifies the center. So we can just do width divided by 2, which is the canvas's width, and I'll get it centered. And then where our text baseline is top, so when we set the Y, it's how far down the top is. So basically, it'll be the gap between the top of the screen and our text. So using those two makes it real easy to position your title when you're lining up. Fill text and stroke text, which is going to have all the same stuff, and it's going to give us our stroke. So fill is the color inside, stroke is the line around the outside. Okay, and that's a little small and a little thick on the strokes. So let's go up to, let's see what maybe 72 looks like, and let's drop our strokes down to 2. Cut it in half. Okay, that's not bad. And get Ben on in here. Okay. And let's drop it down just a little bit more. Maybe. Okay, that's not too bad. Okay, and now, why are you grumpy again? Oh, you have to mark that as excluded or else it thinks I'm duplicating code. Okay. So now, let's go ahead and we will draw on our start button that we made. So let's go ahead up here. We'll just go ahead and load it as well. So start button, load image, public images, start button.png. Okay, so we loaded our image. Now we're going to use draw image again. It's going to be the start button. So for this one, we want to center the image. And for draw image, it's always based on the top left corner. So we're going to do draw image, or sorry, we're going to do width divided by 2. So that will put the edge of the image, I'll put, so half the width puts it right down here in the middle, so it would be like this. And then we'll knock it back half of its width, and then I'll center it right on its middle line. So minus start button dot width divided by 2. Now for its Y, we want to do, so let's actually, we'll align it to the bottom of the canvas and shove it up. So we'll do width, or height rather, so that would put its bottom edge all the way down at the bottom of the canvas. And then we'll shove it up by its height, and then some amount of padding. So minus start button dot height, and that would get it flush with the bottom. And then maybe how much we space this one? We space this one out 60, so maybe 60 from the bottom as well. Let's see, what did I do wrong? Something. Oh, that was the thing. So if you notice, so I had a syntax error here, and my code couldn't build. That's what this error is. Messed up, here's your error. And it wasn't building. So because it wasn't building, we weren't seeing the update code. Now, whoops. Now everything's gone away. All right, so let's see. So we did load our background image. So that's interesting. We never didn't load our start button. That's interesting. Start button. So just like we have here, we should have the start button as well. So it's acting like it never loaded, which if it was like a typo, let's double check. Double check that if, like, say I'm gonna break this URL so it can't load that, it should get in here and spit out an error. Console.error, so it's real angry at us. Nope. Okay, so I don't think our errors are working quite right. So okay. Double check Indian error. Sure that. Okay, yeah, it's called there. And I put on the image. Huh. Oh, you know what? We're not using the image path. That's why it didn't load and why our text broke. We didn't technically have an error, but what was happening was I was drawing our space background instead of our start button, and the space background is huge, so it's filling the whole thing. So we need the image path here. Okay, there we go. And now it also spit out that error that we were looking for, so that's good. So now I'll go back and I'll unbreak this. There we go. Wow, that button is a big start button. Maybe too big. What? I just realized what? Yep. We're not at 100% on here, so everything we did was just a little bit too big. So let's go ahead. I'm just going to resize the whole image. So let's see. So we're at 2460 by 1440, and we were at 66.6%. So I'm going to figure out what that is. Okay, so about 1700. I'm going to link those, so we'll just let the rest do whatever it is. About that. Shrink. Yeah. All right, and I hit save, and so that would copy it into these assets. And I will copy these into where we actually need them. Replace. There we go. That's better. Okay, so now, and you know what? Since we have a dark background for our game and a dark background for this, why don't we go ahead and put border around our canvas just so we can see it better. So we'll do border, maybe 4-pix solid, almost white. Let's go with like that. There we go. Okay, so that's good enough. Okay. All right, so now we need to make it so we can click on right here. Okay, so we've got stuff right now, and we got that, we got the background. So now let's make it so when we click our button, it takes us over to our screen. So to do, click on canvas. First, we have to add an event listener. So canvas.add event listener. Click for a click event, and then we need to capture the event. That's going to tell us our where we clicked, because we don't want to trigger anywhere we click. Like if I click here, I don't want the start button to fire. I only want it if I'm actually clicking the button. And we can see right now it does fire everywhere because the outputs are thing. So what we're going to use is we're going to use the offset X and Y. And this is offset based on the corner of the thing you clicked. So like if I click way up here in the corner, I should get something pretty close to 0, 0 for offset. So there we go, 1 and 4. And if I click down here, I should get something pretty close to 800 by 500, which is the width of our canvas. And yep, so pretty close. So this is what we'll use to tell if we hit. So let's go ahead, let's make a helper function. We're going to call it, we'll call it point hit rectangle maybe, because that's what we're going to, that's what we're going to test. We're going to test that our mouse, that single point from our mouse, does it land somewhere within the rectangle that makes up our button? So we'll do X, Y, and rectangle. And then to tell if we've hit the rectangle, we just do a little bit of math and some Boolean operations. So if we have our rectangle here, and like say this is our point, so we would have, we'll call this Rx and Ry, so the X and Y of the rectangle, and then we have our width and our height, and then we'll call this Px, so point X and point Y. So tell if we are in, if a point is inside a rectangle, we check if the point X is greater than or equal to Rx, and then that the point is also less than or equal to Rx plus Rw, which would be over here. And then we do the same with y. So Px is greater than or equal to Ry, or sorry, Py is greater than or equal to Ry, and Py is less than or equal to Ry plus R height. So we're just going to check that. So, and we're just returning this value, so we're not going to use an if right here. So if x is greater than or equal to ref.x, and whenever I do multiple conditionals, I like to put each one on a new line because it makes it easier to see. Ref.width plus y is greater than or equal to ref.y, and y is less than or equal to ref.y plus ref.height. Okay, and we'll just export default this. Okay, and now over here, I can check if, and we're going to say if not point hit rectangle, because we'll just return and not do anything if it doesn't. And then, so our rectangle is actually, the width and height come from the image. So width, image, height, image, height, or sorry, start button. Right. And then our X and Y are where we drew it. So we drew it here, but remember, so this was this one's actually is our X, or actually they're both our X and Y. Sorry. X, Y. Oh, yeah. Y with height. Okay. So if it's not, we're just going to return, and then otherwise, so down here. Okay. Now down here, we're going to. This means we have hit. So here we'll just say hit for now, and we'll just make sure this is working. So first I'll click around in places that shouldn't hit. So click, 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 click. Okay, so no hits. Now I'll click around in our button, and we can see we look like we're clicking pretty well. I think we're good. Okay, so now what we need to do, so now our start screen is almost basically done. But we need a way to now load up our next scene. So we've got this scene. Now we want to load this scene. So let's go ahead, and just like we did yesterday with Pong, let's go ahead and we'll make a new scene, and we'll call this start screen. We'll call it start screen scene, actually. We didn't do that yesterday, but I tend to like having the whatever type of whatever it is at the end. Okay, and I'm just going to copy all of this over. And just like yesterday, we'll go ahead and we'll actually, we'll use a class. We didn't use a class yesterday. we'll use class. So we're going to have render, and we'll have an initialize, and let's have an exit as well. So this will be called when we leave the scene. Actually, we'll have enter as well. So when we enter the scene, when we exit the scene, when we need to render the scene, and we'll have one more. And actually, let's go ahead, since we're using class, let's go ahead and just make a scene class, and then we can extend that scene class. So we'll just kind of dummy these up here. So class, scene, and so we have an enter, instead of exit, we'll use leave. Leave is usually used more often than exit. We'll do a tick and a render. Okay, and we'll just have that like that, and then we'll export default scene. Okay, and now we'll come over here and we'll have this guy extend scene. And so now what this does right now is, even though this is empty, this is kind of more like an interface right now. JavaScript doesn't really have interfaces, but what it does do is, like, say we don't need an enter and leave, we don't need to make one, but then they still exist, so we don't have to worry about checking if they exist or not when we use them. So in enter now, we're going to, let's move our loading of stuff up, and we're going to make these, we're going to save this, so there'll be properties so we can use them later. And let's also, you don't have to do this in JavaScript, but I like to actually define my properties just up here, just so then when you're looking at your code, you kind of know what exists and what doesn't. And we'll also go ahead, we'll make all of these async. Even if they don't need to be async, it doesn't hurt for them to be async. But that way, if we want them to be async, they can be. So, and actually, let's make tick and render not async, because that would make things tricky for a couple of reasons. Usually don't want those, but enter and leave can be async because they're, it can be like, so we call enter and then we wait for enter to finish, and that way we know that everything's loading. So we could show like a loading screen, but it's going to happen so fast you won't notice. But if you're doing this for real, you would have you'd have a loading screen there, and then once enter finishes, that's when it should be ready and loaded, and you can call render and tick for the first time. Okay, so we're going to do that, and then we're going to need access to the context. So there's two ways to do this. One way would be to pass it in here and to store it. So we pass it when we create it. But I actually don't like to do it that way, because sometimes the context may change for whatever reason in the game, and you may not, and then you have to like try to refeed it to everything, and that gets messy. So I personally prefer to feed the context directly into the render function each time I call it. That way, if in the main program the context has changed, I don't have to go fix anything else. The context just adapts in a different context, and everything stays happy. So now here we'll do this .background, and then we'll do this .start button. Or actually, what I like to do, instead of repeating the word this a bunch, just like we did with the canvas, we can kind of destructure ourselves. And now I don't have to use this button. And the other benefit to that is it helps me avoid accidentally overwriting values that I may not want to overwrite. Like if I do like an equal instead of an equal, it helps me not overwrite things on accident. And then also I'm going to destructure the width and height from the canvas. And yesterday on Pong, we passed in both the canvas and the context. That's actually a little redundant because you can actually get the canvas off the context. So that's what I'm going to do today. That way I just have to pass in the one. So I got the width and height. Now it looks like we have, and we actually do need canvas. So we'll go ahead, we'll destructure canvas off context. And we'll destructure context off canvas. Actually, what did we need for canvas? Oh yeah. So the click event. So the click event we want in our setup too, because we don't want that to happen each time we render. We want it to happen once and once only for the scene, because they'll stay put once it's there. And so that does mean, though, we will need to pass in the context in all of them. go ahead and move this up here. And then this one will just write it off context because we don't need the canvas directly. Okay, so there we go with that. Okay, we'll actually need this up here too. We'll move that out, and we need the start button as well. Actually, for the start button, so we can't destructure it at this point because we're only creating it at that point. So what we'll do instead, if I need to both use it and assign it, I prefer to write it like this. So I'll stick it in a regular variable, and then I'll put that regular variable into this, and then I also just use the regular variable. And then just because I like to keep related things together, I'm going to do it like that. And actually, one thing we can do here too, so with await, because it causes it to wait until this line finishes before it moves on to this line, so this line also needs to wait. It's going to slow things down because it's going to wait for this before it even starts this. So what we'll actually do is we can actually combine these into a promise.all. And what that will do is it'll let each one of these have run at the same time. So we call that in parallel versus serially when you do it one at a time. And we'll put each one in here. And notice I'm leaving behind the await. I'm not going to use await here because I want each one to go. And then I'm going to await on the promise.all. And what promise.all is going to do is it's going to return an array. Okay, it's going to return an array of each of these values we got out here. So we can do we could just do const result, or we can go ahead and destructure them. And the order that these are in is the same order that we put them in. So we can just do start button and background because that's the order we have here. And then we can do this dot start button and this dot background equals background. Okay, so there we go. So now they'll load in parallel, so they'll both load at the same time, so we don't have to wait quite as long. And why are you promise.all takes an iterable? Oh, right, this needs to actually be an array. There we go. Now we're happy. Okay. And now one last thing. Let's go ahead and we'll break each of these lines up into their own thing just to stay nice and organized. And have self-documenting code. Big fan of self-documenting code because then you don't have to remember to update your comments if you try to comment things, because just looking at the code, like looking at the function and variable names is enough to tell you what's going on. It's like, oh, I'm in draw background. It must be drawing the background. And oh, I'm in draw title. It must be drawing a title. And hopefully the code inside each individual function is straightforward enough that you can usually tell. If you can't, then it's usually a good idea to look, can I rearrange my code so it's easier to understand? And if you can, then do that. And if you can't, then that's the time to use a comment. Okay, and we had a bunch of stuff turned green because I'm going to need to pass in some things with the context. We'll pass in the context we get from rendering to each of these, and then we'll destructure off the bits and pieces we need here. So I like to, when I split functions up like that, you can see these guys went gray, so I just know I don't need them. But I paste in all four, and then know just which ones I need, instead of trying to figure it out ahead of time. So there we go. And now I just need to pop each one of these in here. So this dot draw background context, and just as an FYI, so just like I destructured the variables on this, you can actually destructure the functions off of it, but that gets tricky because the whole context and scope of the function, unless you use an arrow function, can get messed up. So I prefer to not destructure function calls, but I do destructure variables. And that's just kind of a stylistic choice, based on some technicalities and just some personal preference. So I'm going to keep using this keyword on each of these. There we go. So now, we have our start screen. Let's export the start screen. Export default start screen scene. And now I'll come over here, and now I'll just create a start screen scene, new start screen scene. Okay, and then I can call start screen scene.enter. I'm going to await that. And I don't need to catch what it returns because it doesn't return anything. I'm going to do the context. Then I'm going to do start screen scene.render context. Okay. And now notice how a bunch of stuff turned gray because the usage for that got moved. So I'm just going to clean those up. There we go. All right, so let's refresh the page. Hopefully nothing's really changed. And start still hits. Perfect. Okay. So now what we're going to do is, so now we want to be able to change the scene. So let's make it change, and actually, real quick, let's go ahead, we'll clean up our file structure here a bit. Yesterday's poem was starting to kind of push the limit. Today I think we're going to go over that limit. I'm going to make a utils function, and I'm just going to throw all of our helper functions in there. And if this kept growing, I would subdivide this more, but for now we'll be good. And then we'll go ahead and we'll make a scenes folder as well. We'll have all of our scenes in there. Okay, and now I want to make a scene manager. So the scene manager is going to manage our scenes for us. Very creative name, I know. I'm really good at that. So, and in this case, what we're going to do is we're going to make scene manager a singleton. So start scene, we actually exported the class itself, and then we called the new to create the scene. For scene manager, we're not going to export the class itself. We're going to make an instance of the scene manager in here. Oops, scene manager. And then we're going to export just the scene manager. And since class can only be accessed in here, and we're only exporting, and we're not exporting the class, that basically makes it a singleton because we can only really have one of them in the whole program. Okay. So now, so scene manager is going to have an array of scenes. We'll go ahead, we'll make this a private. Well, no, we won't. We won't worry about private right now. We'll have add scene. So when we add a scene, we'll reference them by name. So we'll do name scene, and we want that to be an object. And then we'll do this dot scene name equals scene. And we'll go ahead and we'll destructure scenes just because I like to be consistent if I'm going to use that pattern. And then we'll do, if this was fully fledged, we did have like remove scene and whatnot. We're not going to worry about removing because we're not going to use that in our program. It's good not to write code you're not going to need, even though you're like, you think you might need it at some point, unless wait till you really need it before you use it, because then if you don't actually need it, then you just wasted your time writing code you don't need. So, so change scene is going to, we'll have a current scene as well. Current scene equals, or we won't have anything for that. So when we change the scene, we'll set this current scene to scene's name. I'm going to destructure the scene here. I'm going to destructure the current scene. And now notice how I still have this dot scene here. If I want to change it, I have to use this dot whatever, because the destruction one is actually a separate value. And even though it references the same thing, if I change it, it won't. So, and that's kind of how we use that safety net there. It helps me avoid accidentally changing it. And I have to use this, so it makes it real obvious that I meant to change this one. So we'll change the scene here, and then we'll do, actually, before that, because we're going to need this a couple times, let's call this next scene. And then down here, we'll do this current scene at the end. And then we're going to do await next scene.enter, because we want to run the enter code. Oh, and interesting. So here we need to pass in context. We don't have context here. So, but I don't really want to give context there. So that's kind of a quandary. So let's ignore that for a second. Oh, and we need to make this, see how it's yelling at me with this red here? Because change scene needs to be async to be able to do that. So we're going to do async next await.next scene, or await next scene.enter. And then we also want to call exit or leave on the current scene. So we're going to call await current scene.exit. And now we're doing two awaits on the same thing. So let's use promise all, and we'll do both of those together. So current scene.exit and next scene.enter. It's not really going to matter which one goes first or second, as long as it works. Okay, and we'll only do this if we have a current scene. So we'll do current scene question dot. So this, or actually, this pipeline doesn't have optional chaining any of this time. But for now, we'll just do current scene dot exit, and so this will only try to call exit if we actually have a current scene at all. Because like when we first start up, we don't have a current scene, and then because we only want to pass promises into this guy, we're going to do filter boolean here. And so if we don't have a current scene, this will end up as undefined, and so this will filter out that undefined, so we'd only pass one thing in. Okay, and now as for the context, so we have two options for that. We could either pass in, just like we do with exit and stuff, pass in context here every time we call it, but I don't actually want to do that. So let's actually, this would be how I would probably do this in real code. I'm going to make a context manager whose job is basically to keep track of the current context. So the site scene manager, I'm going to make a context manager, and this is going, just like scene manager, this is going to be a singleton. So we'll create a context manager, export default context manager. So we only export one instance of it instead of exporting the whole thing. And then we're going to have variable, and we're just going to have one function. Well, we'll just have one function in here. We'll do set context, and I'll have the context, this dot context equals context. And so if we did do something that changes the context, we would set it here. And then everyone else is going to get a hold of context manager. And when it needs the context manager, import context manager. So anytime anyone needs the context, we'll get it from there. But actually now we can do this, but so can the scenes. So instead of that, let's just go back to the scenes. Let's make it so we don't pass context in to everywhere. We will still pass it into those, but we're going to do context equals context manager dot context. So we'll have this guy grab the context out, and then each one of these guys is going to use it. And we'll do the destructuring syntax, just then we don't have to type out the word twice. Okay, so we'll still pass it down to these, just so that way everyone doesn't have, actually, kind of half a dozen of one, 12 of the other. No, half a dozen of one, 6 of the other. That's 2 days in a row I've tried to use that expression, and 2 days in a row I've messed it up. So we can kind of do this either way. Now that we have this context manager, it doesn't really super matter which way we use. I think I do like it passing in just because it's one fewer line in all those. So we'll do that. And then, yeah, so that's all we need there. And we won't pass it into these guys, so we will have this top level one grab hold of it. We'll edit this. Oh, I never have context to begin with, which is some of my part. Okay, so now we have that, and now this guy doesn't actually need to use context manager at all. Okay, so now we have our scene manager, so we'll go back here, and we will, let's import the scene manager. Okay, and then we'll do scene manager.add scene, and we'll call this start screen. It's a new start screen. Okay, and then we're going to do, we'll call scene manager.change scene to start screen. And we have to await that, which if we need to await it, it has to go on our async. So we wait for the change screen to happen, which is basically the same as this, and then we can render it for the first time. So scene manager dot nothing really should change. Whoops, look, cannot destructure property. Oh, we forgot to feed the canvas or the context into our context manager. Set context. Oops, I need to import that. There we go. Okay. We're still hidden. Good. Now let's go ahead and we will make a game scene. We'll go ahead also and we'll make a game over scene. Just go ahead and make it game over scene and scene. And because scene already defines all the dummy functions, we can just leave it like that for now. Game over scene. Now we have game scene, extend game scene, or extend just plain scene rather. And then export default scene. Okay. And now we'll go back here. We'll go ahead and add all of our scenes to our scene manager. Okay. And we get a squiggle because we need to import them. And I can just use Alt-Enter to import missing things in line. Come back, would you? Okay. I'm just gonna, I like to group similar things together, so I'll change it like that. Okay. So there we go. And now, all that scene manager stuff now, what I can do to actually change the scene now is I'll go to back to our start scene, and then instead of hit, I'm going to do scene manager dot change scene game. Import. Okay, and so now the screen will just go white because we don't have anything in it. Oops, it blew up. Current scene.exit is not a function. Interesting. Oh, because it's not exit. We need to change that to leave. Leave. Okay. Start. Oh, so it didn't show it because we haven't implemented our render loop yet. So let's go ahead. No, get back together. Okay, so now let's implement our render loop. So our render loop is basically we just call render over and over again. And really we want a scene loop to also have tick. I like to call it tick just because it doesn't have to be called tick. You can use it, run frame or whatever you want to call it. I prefer tick for each time. So tick basically is where we'll have our non-drawing logic, our non-render logic, and then we'll have render via our render logic. So zero function. Actually, they don't need to go inside. We'll put them down here because these guys are not async. And the reason we didn't want to make those async is just because we want this to happen every time. And things get a little weird if you have an async render loop because then it doesn't render when you expect it to render and just weird things can happen. So keeping the render loop synchronous is helpful. And we make the stuff outside the render loop like loading async. We just make sure that happens before we try to render. So we have tick. We have tick here, and so we're going to, so the render call, we're going to move into render, the render function. And then down here, so tick itself is going to do whatever, and then we're going to use request animation frame to get the next available chance to render, and we're going to put tick in there. So tick's basically going to do stuff, and then it's going to request another frame so it can do stuff again, and it'll do stuff as fast as the browser lets it, which is usually about 60 frames per second. And inside tick, it's going to call render. So tick's going to do stuff, and then it'll call render, and then it'll call request animation frame. And now all we have to do down here, after we've changed the frame, we're going to call tick once to kick things off. And so now we should actually see it change. Maybe not. Let's try to console. I'll save it tick. Oops. I'll put the word tick instead of function. Okay, so we are ticking. We can see it happening over and over again. Okay. And now we're going to go to Scene Manager. And let's go ahead, or first let's go to Start Scene. And we'll just double check. So it should be changed again. Oh, real quick, let's go ahead and make these constants. That way, if we have a typo in the string, we don't, it'll be more obvious if we, because instead of being a typo in a string, it'll be a typo in a variable. Start string, start string, there we go, and game over. Okay. And we will, instead of export defaulting that, because we're probably going to have other concepts, I'm just going to regular export it. And over here, I'm going to do scene.start string, and let's get string squiggle because I need to import it, so I alt-enter. And notice because it wasn't a default export, it was just a named export, it has curly brackets around it. Scene.game, scene.game over, scene.start screen, and then we'll go use it in start screen scene.game. Yeah. Okay. So now let's go into change scene, and we're going to do console.log scene, and I'm going to make sure that it actually changes. Okay, so it changed there. Click. Okay, it did change. Oh, interesting. So we just have scene here instead of game scene, which is interesting for two reasons. One, it should still turn white. Oh, okay. So, yeah, I know why we didn't change white. First, let's go make sure we exported the right thing. Okay, so we did forget this. We did goof and export scene instead of game scene. So let's check game over and make sure it's good. Okay, so that's good. So now, still not going to go white, but we will get game scene, so that's good. And now the other thing is before we try to render the new thing, we want to get rid of everything on the screen already. So we're going to do clear rec. I noticed I use context manager.context here. I'm actually looking at this way. And the reason for that is because if the context did change from something, we would want to make sure that render is using the most up-to-date one. So we don't want to refer to that directly. I threw it in here, that way we can't. So it helps us avoid making mistakes down the line. And then so here we're using the fresh one. And then similarly, I don't want to use this canvas. I want to use the canvas that comes off of the context for the same reason. Just in case somehow we change that canvas down the line, which in this case we won't be, but still good to do that. And so similarly, I could do this and smash it all together, but that gets kind of ugly and hard to read. It's like, okay, what's really going on there? So what we'll do instead is let's make a couple functions, and we'll group these things up. That way we get some of these declarations out of the global scope. So we'll get add scenes in here, and we'll call this fair context. And now I can go back to having canvas context, and then I'll pass in the context here. And now because these are in a function, that context doesn't get, oops, that's not right. Canvas.getContext. Now these functions are in here, so they don't bleed into other scopes, so I don't try to accidentally use them. And then I'm just going to do prepare context and add scenes inside there to just call those functions. Okay, so now that we're clearing the context, if I hit this, it should switch to game. Perfect, and it cleared it because game doesn't have anything to draw yet. Okay, so that's good. And we can get rid of that. Okay, so really what this top level tick is going to do is just call scene manager dot current scene dot. So it's going to call each of the which start screen didn't have a tick in here because we didn't need one. Start screen basically shows something once and then stays put the whole time. We can get rid of that context. Okay, so let's go ahead with our game scene now. So first, let's have an enter because we need to load up all of our images. So we're going to want to load up the background. And actually, because we have so many images, but the game's also going to have a bunch of other things, let's put all of our images into one object. So this guy is going to have, let's see, how we're going to do. We'll do it like this. So we're going to do a promise set all, initialization, so we need to mark this. Await promise set all, and then here we're going to list out each of our images we want to load. So we'll do load image, public images, and I'm just going to kind of look at the list and go look at the file list on the left-hand side and just grab each one of them. Background, battery. And you know what? Let's actually, because our images are always going to be in the same place, let's get rid of the common part in this URL because that's always going to be the same for all of them. And we'll do the same on start screen. And instead, we'll put them in load images. And that does two things now. One, we can type less, which is always a perk. And two, if we change where we store these, we only have to change it in one place now. So public images, image path. So that'll end up being putting it on for us. So let's go back to battery. And actually, well, so we could remove the .png as well. And sometimes you might want to have like a JPEG or something, so you might not want to do that, but in this case we will. So dot .png, and yeah, so that should be good. And then let's just make sure we adjust all of our other things accordingly. Okay, so background, battery, enemy, health, chart. Actually, you know what? Let's get kind of extra fancy with this. Let's make just an array of strings. Background, battery, enemy, health, archetype, part, laser, play again, ship. Oh, we don't need play again. And we don't need start button. So we'll do that, and then we'll do map, load image. And so what this will do is for each one of these strings now it's going to call load image. And then so you will end up with an array of promises from here, which goes into promise all. So, and now here we'll destructure out our array and create one variable for each. So background, battery, enemy, health, part, laser, ship. Okay, and then we'll go ahead and to this.images, we'll just stash all of them in there. So we're going to call do background. Actually, you know what? We'll just let them all be lowercase names since they're not really constant. They shouldn't be uppercase, right? And it's also less typing, so yay. Okay, so now all of our images are loaded, and then they're all loaded into this image object. So we're good there. And then let's go ahead now. We'll do render. First we'll get the background showing. So let's, just like the other one, the other render function we did in start screen, I'll grab the context off context manager. We're using the destructuring syntax, and then we'll make a different function for each, and we'll pass in the context there. So this background context. Okay, and now we'll grab our image. We'll grab the background out of images. Nope. Background, and then we'll do context.draw image, and so the background is eventually going to move, but for now we'll just do 0, 0. We'll just put it somewhere. Actually, background comes first. 0, now we should have a background. Start. Okay, cool. And because I don't want to have to hit the start button every time I refresh, I'm going to go ahead. I'm going to, where I change the scene here, I'm going to temporarily instead change the scene to start on game. Okay, there we go. So now game comes up first every time. Okay, and we'll change that back later. All right, so there's our image. Let's go ahead. We'll draw our ship now. So let's draw ship. And this is pretty similar. Image. Okay, and so our ship is obviously also going to move. So let's go ahead and we'll make a let's make an object for ship. And inside of it, we'll just put an X and Y to start with. So I'm just going to kind of pick some numbers. We'll have to set those something when we properly load up, but for now we'll just do those. Oh, except now I've done ship, but I also have this ship. So if I want to destructure this, now I have two things trying to go to the same variable name. So we'll call this ship image. So when I do a colon in a destructure like this, it means that we'll refer to this as ship image. So ship image, ship.x, ship.y. Okay. And then I can actually smash these together and do it like this. So you notice here, I didn't use a colon because I typoed. There, now I use a colon. There we go. So here I'm destructuring images one step further and grabbing out ship and then ship image. So the white two are the ones that actually come out of that. And you'll notice here, so when I use a colon, it actually has two different things it can do. If it's a colon to just one word, like a variable name, then it's renaming the variable. If it's a colon to an object, that's saying grab stuff from inside of here. So I'm saying grab stuff from images, I want you to grab ship, and I want you to call that ship image. So that's what's going on there. Okay, so let's go ahead, we'll refresh the page. There we go, we have ship. That might be a little bit, but it'll be okay. Okay, so let's go ahead. So we'll do one thing at a time. Let's get the ship in position and moving. So we'll do this stuff. So let's start our ship out in the middle of the canvas. So let's put that on enter. So we'll reset the ship's position every time we start up game. So we're going to do this.ship equals, and we'll have that stuff. And now the X we want to be in the middle. So we're going to have to do that as, so let's get the context up here. So we'll just go ahead and grab the canvas. We don't actually care about the context. We want the canvas off the context. Destructured off of there. Okay. So down here for the ship, we're going to do canvas.width divide by 2. So that'll put the ship's left edge in the middle of the canvas, and then we move it back ship's width by 2. And because at this point we've loaded all of our images, ship will have a width. And then the Y, so I think we'll have it so the ship can basically go up to the halfway mark. We'll start it kind of towards the back. So we'll just do like maybe, I don't know, 20 pixels from the bottom. So to do from the bottom, we'll do canvas.height. So that would have the top edge of the ship at the bottom of the height, minus ship.height. So that would have now the bottom of the canvas right at the bottom, then minus 20, which will have the bottom of the ship 20 away from the bottom. Okay, so let's see how that worked. Okay, so there we go. So now we have the ship drawing. And let's go ahead, let's split this into its own function. Load images. This will need to be async, so we'll await it. Load images async. Okay. And now we will actually need to grab the ship again. So const shift equals this sign, so we'll just destructure off of there. Okay. So, all right, we're still good. All right. So now let's look up our movement. So we're just going to use the arrow keys, so left, right, up, down. So first we will. So yesterday we just kind of put the input into the game scene itself when we did Pong. Let's actually make an input manager. I like to have managers for these kind of things because it makes it more reusable. So input manager. And just like our other two managers, this guy's going to be a singleton. Manager, and export just the singleton of it. Okay, so now this guy, just like we did yesterday, it's going to have a keys down, which will be all the keys, all the buttons that are currently pressed down. And then we're going to have a handle key down. We're going to have a handle key up. Okay, so these will hook up to our event manager, or to our to whatever we're listening on. So what we're going to do is we're going to have a constructor. So as soon as we create it, we're going to go get the context manager's context. That's what we need. Or we need the canvas. So we're going to have. Let me put that in variable. We'll need it twice. Okay. So we're going to take the canvas. Or no, sorry, that's all wrong. For input, for keyboard input, we need to listen to something that can have focus, which is usually like an input element or something. But in this case, since we really only have one keyboard thing, we're just going to hook it straight to document. So straight to the top level, and we'll capture everything. Document.add event listener, key down. We'll say handle key down. We're going to use our function calls down there. Just handle key up. Okay, and now here we have a tricky thing. So with our scope and our context of what the function's running in, this context. So when we do something here, I'm going to want access to keys down, which we would access by keys down like this. But there's a tricky thing with how I've done this. So I'm going to console log this here. And let's go see what happens when I hit a key. So nothing happened. Oh, because I didn't actually create. Oh, no, I didn't import it here. We have to go import it somewhere, or else that code will never run. But actually, we'll just import it into C manager, because that's the only place we really need it. Input manager from input manager. Okay. Now that code should load up. Okay. So notice that. So I console logged this, and we were probably expecting this to be input manager, but notice this is actually document. So our context got all screwed up because the context, when you have an event handler, is this is the element that was on normally. So what we want to do, instead of using these regular functions, these regular class member functions index, we're going to use an arrow function. And an arrow function binds the context of this to whatever the context is when we create it. So because it's in the context of input manager, this is now going to be the input manager, no matter what. So now if I click button, input manager. So there we go. So that's real important when you're using classes and you're passing in event handlers like this. You want to make sure that those event handlers are this, or you could alternatively call bind here. But that has some problems because then if you want to remove it, calling bind this again on the same thing actually gives you two things. So it's not the same thing, so you can't remove it. So the arrow function approach is usually your easiest approach. And now, just like we talked about yesterday, I'm going to output the event so we can take a peek. We have a couple different things we can use to tell what we hit. We could either do code, or we could do key, or we can do key code. So we'll use key. And so we want to use left, right, up, down. So I'm just going to hit left, right, up, down. And we can see the code for each one of those is arrow left, arrow up, arrow right, and arrow down. And then let's go ahead and our constants, and we're going to just throw those strings into a keys function. So arrow up. Or actually, let's do call these input keys. And just like we did yesterday, instead of recording just the generic keys, we'll record what what the button's done. So this is basically like our key binding, like you would do in a video game, except hard coded in this case. So move up would be arrow up for us. Move left would be arrow left for us. Move right, arrow right. Move down, arrow down. So that's like our key binding. And then, but in here now, we're just going to do this dot keys down dot push and that dot code, so we keep track. But we don't want to have the same key in there multiple times because it makes it hard to move it then. So we'll check if this dot keys down, and actually let's go ahead with destructure keys down. So if keys down dot include key or event dot code, we're just going to return. We won't do anything. We'll pop out. Otherwise, we're going to push it on. Okay, and then keys up is going to be similar. We want to now take it out of keys down if it exists. So destructure keys down again. And now we'll get an index of the key, an index of net.code. And if it isn't in there already, we'll have an index of -1. So if it's a -1, let's just return, we'll bounce out. And if we do have it, we're going to use keys down dot splice, and we're going to start at 0, and we're going to delete 1. And so that'll take it out. And now here we'll do a helper function. We'll do is key down, and we'll call this code. That's what we're using. So we'll just return keys down dot include code. So if it's in there, then that means we return it. And we'll also do we could do an is key up for completeness, which would literally just be not is key down. But we're not actually going to ever check if we have key up because we don't really care. So we'll just stick with this key down. And also, just for clarity's sake here, let's use that helper method for here as well. So is key down that.code, just because then it makes it even clearer what we're checking. Okay, so there's our input manager. So now over in the game, to make it move, here we're going to, in our pick function, we're going to check if each of those keys are down, and we're going to move it. So if input manager dot is key down input keys dot move left, then we're going to move left. And for now, we'll just go ahead grab the shift. Let's go ahead and just kind of move it hard coded a little bit. And we'll fancy this up in a bit. So remember, left and up are negative, down and right are positive. Down, input keys dot move up, line minus, negative, input manager dot is key down, input keys dot move down, shift dot y plus. Okay, so now every tick, which is probably about 60 times a second, because FPS is about 60 frames per second, which is because that's just what request animation thing runs at on my computer. We're going to check for each one of these. And actually, so how I did these here is actually not good because I did an else. So we can only possibly do one movement. So like if you watch, so left, now I'm holding up, but because left came first, it doesn't do anything. Or if I hold up and then I hold down, I can't do anything. So let's actually unnest these so we can potentially hit all 4 keys at once. And if you hit up and down at the same time, it doesn't really matter. But now I can move in all directions. So now, though, we said we only want to let me go halfway up, and I can kind of go forever, and I can even go off the screen. So let's go ahead, let's make a clamp function. And a clamp function is just, it clamps a number between two values. So we'll do clamp.js, clamp equals, and then we pass in the value, the min and the max. And then it looks a little funny here, but we actually check the max with the min, and we check the min, check max for, no, check min for max, a value, because we want it to be in between those two. Oh. Someone's not a fan of JS. I love it though. Not actually for game development, but it's fun for learning. Okay, so export default clamp. So now what we'll do here is for each of our for the ship, we'll clamp the X and the Y to be within our values. So ship.x or ship.x equals, and then we'll pass in ship.x to clamp it. So the minimum for X would be the left side, so that would be 0. And then the maximum would be the canvas's width. So let's use context to get a hold of the canvas. So equals context manager, context, and we'll do, so it's canvas's width, and then minus the ship's width, because we want the right side to stop at the right side of the canvas. And then similarly, ship.y, 0, canvas.height minus ship.height. And then we get a squiggle, I need to import that. Okay. Our ship has disappeared. Interesting. Did I mess up clamping? Let's console.log. Oh, you know what? Did I return a value? No, I return min, max, min value. Yeah. Alright, so let's see what our ship changes to. I'll just output this here. We're going to get it a bunch of times. Oh, it's not a number really quickly. How did we end up on not a number? So that would mean probably that clamp didn't return what we thought it was. So this. And we'll output each one of these pieces here. We'll output the whole thing, and then we'll output each bit individually so we can see what we're passing. We don't need passing zeros, so we'll just do canvas.work. Okay. Oh, and you know what? We may be trying to use, we need the ship image width here. So we could go grab the image again, but let's actually, instead of that, we'll just, when we initialize ship, let's just load the ship image width onto here as well. That way we always have it, and that makes ship a full rectangle, which will be handy when we test collision. There we go, now we're back. All right, now, let's crank this up a little bit. Minus equals 3. And this is still temporary. We're going to swap it out for something fancier in just a second. But just so we can get to the edge faster. Okay, so good. I stopped there. And we only want it to go halfway, so we need to tweak that still. But let's check. So I'm holding the buttons to try to go off screen, and it's kind of keeping me there. So, all right, so that looks good. And now for half the screen, that means our Y's minimum is actually half of canvas's height. Or, yeah. Okay. So now, there we go. So now I stop halfway up, which is good. Okay, so now that we have that moving, let's go check that off. Check. Okay, let's get the background moving. Okay, so the background is going to move down, which is going to kind of give an illusion that we're moving forward. So for that, we'll just, so first, when we move, when we do things over time in games, we have two ways of doing it. First, we do it fixed frames per second, and then we can do it based on how many, each frame we move at a fixed amount. That way is not great because A, no one likes a fixed frame rate, but B, B, even if you did a fixed framework, it could lag, and if it lags, then your frame rate's actually lower than you expect, and it doesn't work quite as well. So we're going to do it based on time. What we're going to do to our go to our main tick function. We're going to, up here, we're going to grab hold of the last time. So, and this will be basically when we start. And then at the start of our tick function, we're going to grab the current time, and then we're going to get the delta. And so the delta is our difference between our last time and now. So that tells us, and then we pop last time into now. So this tells us how long it's been since the last time we ran a tick. So then we can do everything based on time, and it'll work whether we're running at like 5 frames per second or 1,000,000 frames per second. So the like speed things moves will still be the same. And then we're going to pass that delta in, and since most of our math we're going to do based on seconds, this gives us milliseconds. We'll go ahead and we'll divide delta by 1,000, so that'll be seconds of delta. And then we go back to our game scene and we'll just accept that. And so now in our background, so let's go ahead, let's move all the ship logic into an update ship function. Just to keep things from getting too complicated. And then we'll call update ship in here. Okay, and then we'll also make an update background function. Okay, so our background is still getting rendered in here, and that bit's not going to change. But we want to keep track of where our background is. So let's make a background Y. We'll just start it at Y, or at 0. And then we'll basically just say this, let's have delta into these guys. Okay, so we'll update background Y by some amount, and I always like to, whenever you have values that you may be fiddling with, I always like to put them as constants up here. That way they'll be all in one place to fiddle with. So we'll start out, we'll do a background speed of 10 pixels per second. So we'll do plus equal delta times background speed. And so this will scale it to give us the right number of pixels to move each second, because this will only be a fraction of a second, so we don't want the full 10, we want some number below 10. So that's where we'll start out. We didn't use background Y. So let's go down here, and now we'll grab background Y, and then we'll push this up. Okay, and then our X is never going to change. We'll have our background Y change. Okay, and now, well, okay, 10 pixels per second is too slow. So let's go with maybe see how bad 100 is. Okay, and I have it moving the wrong way, and so it actually kind of looks like our ship is moving backwards. And notice too that we don't have it continuous because we ran out of background. So first let's go flip it around. So we could flip it down there, or we could flip it here. We'll just flip it here. So now it's moving the right way. But now notice, so we want what's called a parallax background, and that's basically an infinite background that repeats. So we'll go ahead and we'll to do that, you basically need at least 2 of whatever you have drawing. So we'll draw one background just like that, and then we're going to draw another background on top of it. So this one, its X will still be 0, and its Y will be background Y minus background dot height. And so that'll stack it on top of it. Now if we move, and we can see we didn't make it seamless, so see the little seam here. But if it works right, which it won't, because we need to do one more thing. We should run out of background. There we go. So now we have to make them flip. So like we have 2, and then they're going down, and once the one gets off screen, it moves to the top. And so you never actually run out of background. So to do that, the easiest way to do that is we'll just change background Y whenever it gets too high. So background Y, so if we have, if we start a background at 0, by the time it gets to here, that first background is totally off the screen. So that amount would be 500 because that's how tall our screen is. So basically what we'll say is every time we get, well, except in this case, so at 500 it could move, but then it's going to create something janky, and I'll show you what it does. So we'll do this background Y. Well, it's not really what you would do anyway. So if you got above 500, you could subtract 500, but then it's going to keep jumping back up. What we actually want to do, so if we want to mod it by the background image is height. So images, background, images. And so what that'll do is once we get to the height where it's off, it should jump back up to the top. Well, it won't really jump to the top. What's really going to happen is they're both going to move, and then when the one gets off screen, it's going to jump back up. But that jump is instant, so you don't see it. So see, we can see our line coming here again. And then we'll watch for it again. There we go. So see, we can, so now it'll go forever because the two are constantly resetting. So we never see it move back, but it always does. And now let's go ahead. We'll go tweak our image to get rid of that line. I wanted to leave it so we could see it, but now we can get rid of it. So a couple ways to get rid of images like, or things like that. The easiest way, though, let's switch these down, is if you move your graphics down and up, so inside the actual image itself, you create the line. Well, that's funny. I don't actually have a line in here. But interesting. Maybe we can go put the line out there. Interesting. Okay. Well, let's just save that and see what happens. But normally what you do, oh, actually maybe I can I see a line? Now I might just be going crazy and thinking I see a line. No, because I thought I saw a line down there. Okay, that's right. But normally what you can do though is if you stick the two parts together, the edges, you can blur them or do however you need to fix it. Depends. But how you do it depends a little bit on what you're trying to make continuous. This one's real easy because it's noise basically. If you were doing like a repeating pattern, you may have to, depending how the pattern is, have kind of adjust it and stuff. Okay, so we'll put this directly where it needs to go inside of it. Let's see if that line disappears. It's kind of weird that we had a line. Yeah, we still have a line. Interesting. So that may be that Photoshop doing magic, and then I don't know, maybe we can kind of see a line. So what I'll just do, I'm going to go ahead. I'm just going to kind of snag. Hang on. Let's first trim the canvas real quick, just to make sure that. Because I do have kind of a border here. So let's go ahead on the left. I'm seeing a border on the left and right. So let's go ahead and smash that down and then duplicate. And then I'm going to drag this one over this way. Drag this one over this way. Yeah, Photoshop, I think it'd be nice to me in blurring that, even though I don't want it to. But what we'll do here, we'll just we'll just chop out a slice in the empty space. I'm just going to drop that on top of the line, and hopefully that'll be good enough to Merge. I'm just going to grab a space that doesn't have a bit of star in it. Let's drag it down to the seam, I think was. I can't actually see the seam. You just kind of barely see it moving over that. Okay. Seam. Export, quit export. No, I'm still on the seam. Funny, I've never actually ran into this problem where I don't see the seam in Photoshop, but I do in the program. Yeah. And actually, it's funny because the seam has moved with the image, which means it's not actually like a seam in the graphics. It's more like Photoshop's like an edge on my image, and you can kind of see that here. See how there's like I think that's what we're seeing, but we don't actually see that when we zoom in. It's like what Photoshop's doing exactly. Export. All right, well, let's not spend too much time on that. We'll just leave that as is for now. I think if we just recreated the background, it would work, but okay. So now let's look at what we're doing. So we have now our background works. Our background moves. So check on that. We have our ship moving. Let's go ahead. We'll draw the lives now. So we will give the ship lives. Let's start with 4. And let's make a draw lives function. Draw lives, pass in the context. And then, so we're going to grab the ship because that tells us how many. And we're going to grab the lives. Also that. And so for this one, we're actually going to draw the heart multiple times. We're going to draw it 1 per life. So let's see. So we'll use a for loop since we know we have a fixed number of things we're doing. We'll use a for loop. Usually, if you know your start and end, the for loop's good. While is better for if you kind of maybe don't know the end. Okay, and then so for each of these, we're going to draw them. Draw image. It's going to be the same image each time. And then we're going to start, so they're going to be in the top corner. So let's make it maybe maybe 10 pixels from the edge and 10 from the top. So we'll do 10 and 10. And then this will draw them 4 times. Whoops. Oh, I should draw images. Draw image. So this is going to draw, do the thing I say. Yeah, draw an image, provided value is not the type, blah, blah, blah. Okay. Is it not called light? Oh no, it's called heart. 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 Okay. So do it 4 times, but all 4 on the same spot because we just do 10, 10 in here. So what we're going to do, we'll do 10. So that's 10 from the edge, and then we're going to plus, and we're going to multiply it by some I, or by what I is. So I will be 0, 1, 2, or 3 if we have 4 lines. So we'll multiply that by heart.width. And so if we look at that, and technically because order of operations makes this go first, we don't need parentheses, but just for ease of understanding, it's nice to put parentheses in. So that gives us 4 hearts. They are kind of touching each other. If we wanted to space them out, which doesn't actually look too bad for these, if we wanted them spaced out, we could just add a little more here to the width, and I would space them out. But I think they actually look okay smushed next to one another. leave it like that. So there's our lives. Now, so that was pretty easy. So boom. And then just as we change our lives, that will automatically get redrawn with our number of lives. Let's go ahead, we'll do the score. So let's attach, we'll just do score as a separate value. Score equals 0. And we actually want to remember to do, well, we'll do that in a bit. So score, we'll just draw the score. So just draw score. Okay, and then score is just text, so we'll just get the value for it. And we're going to do a fill style, we'll do white for the text. We'll do text align center, so it's easy to center. We're going to do text baseline top, so it's easy to get on top. And then text dot fill text, so the text will just be the score itself. And then we're going to do we need the context, the canvas from the context, and we're going to do width divided by 2 to put it in the center of the screen. And because we centered it, the text already, it'll be centered on that line. And then we'll just put this about 10 away from the top. Oops, and do I have a syntax here? Yes, I do. Oh, and one parenthesis. Oh, then actually get rid of that. There we go. Okay. And there's, okay, so we want to crank up our font size considerably. So context.font equals, 40 pixels, and we'll just do the Arial Helvetica sans serif text. Okay. All right, so that's not too bad. And let's actually, for a lot of arcade games, we'll go ahead and like show the extra zeros. So let's do that. So let's make a helper function called pad. Actually, we'll call it pad before, so we know that it's going to pad text before it. And then pad before equals, so we have the string. We'll pass in the length, how long we want the overall to be, and we'll pass in the padding, which will be what we pad with. And then basically, there's a couple ways you can do this function. The easiest way is we'll make an array of length, and then we'll fill that with the padding, and then we add that to the string, and then we trim, or not trim, we slice the string, and we start it at negative length. And so that's a couple things going on. So let's see it first, and then I'll kind of break down what we're doing there. So pad before, and then we're going to do on score, pad before, 4. Let's say maybe 10 digits, and we'll pad with zeros. Ooh, oh, we need, before we fill, we have to join. Join with nothing. Or no, sorry, after the fill, before the join. There we go. Okay, so there we go. So what we're doing there, kind of a lot going on, but it's rather straightforward. So I'm just going to copy this, and we're just going to play with it in the console here. So I'll go ahead and make a string for ABC. Okay, and make a variable for padding and length as well. So length for 10, padding equals, okay. So now I'll run it, and you can see that it just works here now each time I run it. So what we're doing is first, we create a new array of length. So even though length is the ultimate size we want, we can actually make it bigger, and then then we slice it off, because that guarantees, because like we don't know right now if string is 1 character, 15 characters, or 0 characters. So if we make an array with that many things, with the maximum number we could possibly need, and then trim it, that's easier than trying to, figure out how many we need specifically. So when you make a new array, you end up with this empty here. Then we call .fill, and what that does is put value in each of the spots that the array has. So we end up with 10 of those. Then we call join, and we pass in an empty string. So that joins them all together in one string. Then, when we use a template function to output the string, we end up with all of those and then the string at the end. And so this is actually longer than the length we want. And then, last but not least, we use slice, and we do negative length. And when you give slice and negative as the first value, it'll get however many length it is from the end. So we end up with padded however many of the paddings we need, and we end up with something that's exactly length long. So that's what that's doing there. Okay, so we have our score now. That's another thing ticked off for our program. Tick. So now let's go ahead. We'll make it so we can shoot. So we have bullets now. So for our bullets, we're going to have more than one bullet on this screen at a time. So we'll have bullets, and we'll make that an array. And then let's go ahead. We'll make it so when we hit space, we fire. So we'll go back to our constants, and we'll use fire. And this is like our key binding. So I'm pretty sure it's space. We'll see very quickly if I'm wrong with that. And then let's go into tick. So we'll just call this fire for now. Fire, excuse me. And so we don't want to be able to fire every tick, because that would be 60 shots a second. Well, here, let's just do that because it's going to be fun to see. So we'll check if if we're not pressing space, we don't need to do anything. So we'll just do a not is key down input keys dot fire. So if we're not doing that, we'll go to return. We're not going to do anything. So if we are doing something, we're going to make it a new bullet. So we just need kind of the data for it. So it'll have an X and a Y. So the X of the bullet is going to be the center of our ship, and we'll center the bullet on top of the center. So we're going to like shoot them right out of the pointy part of our ship. So right out of here. You could alternately, if you wanted to have like two shooters on the side, but we're just going to say like we have a laser gun mounted right below us. So to do that, we need to know the width of the ship and the width of the laser. So let's go ahead and we'll destructure after we bounce out in case we don't need these. So we'll do ship. Actually, we'll need the ship itself. As ship, we put the width and height, so that's good enough for that. And we'll just do images, and we'll do, this is called the laser, right? Yes, laser. Okay, so this will be ship.x, so that's the left-hand side, plus ship.width divided by 2, half the width of it, so we get in the center, and then subtract half of laser's width, so we center the laser on it. And then the y, we'll fire it like from under the ship, so the y will actually start at the same y as the ship, and it'll just be underneath the ship for a moment. So we create the bullet, and then we're going to just push it onto bullet. So this will make the bullet, and then let's go draw the bullets. And so if we want them to appear under the ship, we need to make sure that we do it before the ship. So we'll make a draw bullet. I'm going to try to keep these in the same order. So I'm going to put this here, draw bullet. Okay. And now, so this, just like the hearts, we're going to have multiple drawing. And so we're going to need our bullets object, which tells us about the bullet. And then we need the laser image. And just we'll do a for since we know how many we're doing. Just bullets.name, I++. And now we'll do context.drawImage. And this one's pretty straightforward. We just need to do the laser. And we'll do bullet I. Actually, you know what? Instead of a for loop, since we already have an array, let's use for each bullet. tend to like for each better, because then we won't have to do bullet I and stuff, because we don't actually need an I in this case. So we can just do draw context dot draw image laser bullet.x bullet.y. Nice and simple. That was pretty easy. So let's go see if it works. So whoa, everything blew up. Bullets dot for each is not a function. Okay, that's interesting. So what did I do? Yes. I accidentally, instead of pushing the bullet on, I just set the whole bullet to that. So now let's try it. Okay. So it fires, and see, I can hold down. So we have two things here. First, we want to fix the fire rate because we don't want basically infinity bullets. So that's one thing to fix. And then the other thing is we need to, each tick now, we need to move them forward because they're naturally moving themselves. So in tick, we're going to do an update bullet. And the reason, just in case you're curious, the reason I'm calling this bullets, but even though it's a laser, we added others or something, I would just call them all bullets, but we would still have, you know, they'd all still shoot update bullets. Okay, so here we're going to do, for each bullet we have, we're going to move them forward by their bullet speed. So since we only have one bullet, we'll just make a bullet speed. And let's see, these should probably be faster than the background, so they look like they're flying away from us. So let's try 300 pixels a second. And then, so we'll just do bullet.y, and they're moving up, so we actually want to subtract bullet speed times delta. And that's all it takes to move them. Now, whoops. Bullet.y, yeah, it should be moving up. Is it a negative bullet? Bullet space. Positive is down, negative is up. That's weird. That's kind of funny. We have like a tail. Yeah, what did I do? Didn't forget how X and Y work, did I? Minus equals. Okay, let's just do this. Bullet, bullet speed, delta. Okay. Oh. Well, that's interesting. Our delta somehow went negative. How on earth did we end up with negative delta? Huh. Okay, well, delta comes from here. Oh, these are backwards. Now and last time. Because now will be a bigger number than last time. Okay, that actually means our background is backwards. So let's go take a peek at that. The background, yeah. And you know what? I think I did plus equal the first time, and that's right the first time. I just didn't realize it. Okay, so now we have bullets moving forward, but we have way too many of them. So, I mean, we're firing off, you know, crazy number of them. That's kind of unrealistic. The game would be super easy. You just go da 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 da. So let's go put a rate of fire. So we'll say bullet rate of fire, and let's say we can fire maybe 2 bullets per second. Okay, and then so to regulate that, we need to have a last bullet fired, or we'll just say last fired. Okay, and then we'll just start that at 0. So it doesn't really matter what it starts at. And then when we go to fire, let's check. So now we have 2 things that may cause us to skip this function entirely. We may, if we're not pressing the fire button, or last fired, or last fired minus date.now is less than rate of fire. So if the last time we fired minus, oops, and I just did that backwards again, minus last fire. So if the last time we fired minus, or is now minus the last time we fired, that'll give us some number of milliseconds. If that's less than when we fire, less than our rate of fire, no, that's a little wrong because I said 2. So this actually should be 1,000 divided by 2. So we convert to milliseconds. 1,000 divided by 2. So if this number of milliseconds is less than 500, it's not been long enough for us to fire again. So then we'll just return. And since I'm not putting that on my line, I'm going to curly brackets. Okay, and so then we keep firing, and we'll just want to record this dot last fired equals date dot now. And because I don't like calling things multiple times, let's throw date dot now into a now. Okay, so now let's see. That should regulate. Oh, and let's get rid of that console log. Okay, so there we go. So now I'm just holding down space, and we can see now we'll get 1,000, 2 1,000, 3 1,000. So there we go. About 2. That may be a little slow. Why don't we crank it up? We'll do 3. And this is why I put all those values up top, because now we can play with them. There we go. That's not too bad. That may still be a little fast, but that's good enough. Actually, I think our bullet's a little long. So I'm going to go back to assets. And I'm going to shrink it down a bit. There we go. And actually grab it. Actually, I think it's a little wide too, so I'll shrink it all together, and then I'll also shrink it just down. A little stubby. Actually, let's ditch that stroke as well. Okay. Maybe now it might be a little too short. File, export. No. Oh, we're doing generate, so let's just save it and then copy over. All right. So, there we go. That looks better. Pew, 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 pew. Okay. Cool. So that's another thing checked off our list. We have what's done. Okay, so now let's get the enemies in here. So enemies are going to be kind of similar to bullets. We're just going to basically, every so often, add a new enemy to the game, and we'll kind of pick a random X position for it to be at. So we'll do a enemy, and we'll go ahead and do an enemy speed as well. Let's see, maybe 200, a little slower than the bullet, faster than the background. And we'll do an enemy spawn rate. And let's say we maybe spawn one every 2 seconds. Okay, so now in tick, we're going to do this dot update enemies. Update enemies. So actually, we'll break it into 2, just like we did fire. Let's actually, we'll put fire up here, and we'll do spawn enemies up here as well. And we'll have update enemies, which just move them. Update enemies and spawn enemies. Okay, so we'll do spawn enemies first. So, just like with the rate of fire for the bullets, we need a last spawn for our enemy. And then this is going to work pretty similar, except we don't need to check the key down. We'll do a, still the same stuff. Except we're not going to do this anymore. And then instead of last fired, it's last spawn. We're going to grab, we don't need the ship, we will need the enemy. And the, actually, we should have the structure bullet down here. That's actually where, when I did this bullet equal bullet thing, that's actually where the whole destructuring protects you from, because you can't accidentally replace it if you're not using this. It wouldn't work out properly, but it would work. Okay, so now we'll check. So if now minus last spawn is less than our spawn rate, will return. And then just like bullet, we're going to make an enemy. And now in this case, we're going to randomize it a bit. So we'll do, we'll say, so max.random, we know we need a random. Now give us a decimal number between 0 and 1. We're going to multiply that by the canvas width. So when we grab the canvas, context, so we get canvas.context, canvas.width, and then we want to make sure the enemy's on screen. So we don't actually want it so far next at the edge, so we need to subtract by enemy.width. That way we are keeping it on screen. Block scope variable. Oh, we'll call this one enemy image. It was confused because I had it up here and then I was trying to redeclare it. Okay, and then the Y, we're going to just spawn it right above the screen. So we'll do 0, we're basically doing 0 minus enemy image.height, but we can just call that negative enemy height. And then we just add that to enemies, which I forget to make an enemy array. I guess I did, yep. So enemies. Okay, so we push that on there, and then we just update last spawn to be now. Update that so we're not grabbing now again. Okay, there we go. So now that'll put the enemies on in there, but they're going to be off screen, so we can't see them. So let's go ahead and do update enemies. Actually, here, just temporarily, we'll drop this down to 130 so we can see them. But first, we need to draw them before we can see them. So let's go. We'll do a draw enemies, and we want our enemies to appear behind our lives and our score. So let's make sure they're before lives and score. To draw enemies, I'm going to keep these in the same order. So draw enemies. Okay, and this is just like pretty much sports as well. And this, and then enemies. Enemies. Oh, no, the same variable name again. So we'll call this enemy image. So context draw image enemy image. Enemy.x, enemy.y. Okay, and now we should see enemies appear. So there we go. So we're not moving them yet, but you can see them kind of popping in. All right, so now let's go up here and we'll make a move. And so this is pretty much exactly like the bullet. So for each enemy, we just update their Y, and then moving down, so we're going to add to it. We're going to do delta times enemy speed. Okay, so now, there we go. And now, see how they're popping in? Let's go take that 30 off. We'll do that instead. Okay. And they're probably moving a little quick, and they're probably spawning too fast. It's pretty quick. Wait, what did we do? We did 2 per second? Yeah, that's too many. Let's do 0.5 a second. So we get 1 every 2 seconds instead. Okay, and That might be a little low. So we'll stick with that for now. Okay, so now let's go ahead. So one of the kind of downsides of this now is it's really just kind of predictable. I mean, it's like 1, 2, 1, 2, 1, 1,000, 2, 1,000, 1, 1,000, 2, 1,000, 1, 1,000, 2, 1,000. There's like no variability to it, really. So what we can do is let's go randomize the enemy a little bit. Because enemies don't really, unless you're fighting the British in the 1800s, don't really come at you in a neat, orderly fashion. So let's go ahead. One way we can randomize it is we'll just shift their height a bit so they don't all spawn at exactly the same height. That way, like one will spawn, and it may take it a little longer to get down to you, so they'll be not quite as regular. We'll do this, and we'll say we'll go make a new constant called enemy variability. So that'll be enemy spawn variability. So we could also vary the spawn rate, but this gives us effectively the same effect. And so we'll say, let's do like 300 pixels. So there's up to a 300 pixel difference between them. And we want this to be negative. So, or not, so plus, and then we'll make that negative. Oh, or we can just say minus. That would be smarter. There we go. So now they will come in not quite as evenly. So see, those two are kind of close, and then that one's far apart, and then that one. Okay, and let's speed that up just a bit. That's a little too slow. We'll say 1 MB per second. Okay, so see, those two are almost the same because the first one was a little behind. So there we go. That's not bad. And then similarly, let's go ahead and let's put some variability in the speed as well. Not all enemies are as fast, so we'll do speed variability. And let's say, so 200 pixels is going to be our slowest. So let's say one could have up to 300 more pixels added to it. So it could be moving at up to 5. And then what we'll do here, when we generate one, let's give it a speed. And we'll do enemy speed plus math.random times enemy speed variability. Oh, and let's go ahead, since these are pixels and we don't want to deal with subpixels, let's go ahead and floor all these so we get nice even numbers. Floor. Okay, so now, and then let's go make use of this speed when we update. So instead of just this hard-coded one, we'll use the enemy's own speed. So now, so that one's moving pretty fast. That one's moving fast. Ooh, that one's real fast. That's probably a dodge instead of a try to hit. Okay, so there we go. So see, that was a little more interesting just by changing a couple little things. So now we have our enemies, and we have basically everything on the screen now except our power-up. So we have enemies. Now let's make it so we can actually interact with one another, because right now we're just kind of phasing through one another. So first, let's implement when the bullet hits the enemy to destroy the enemy. So we'll go ahead, we'll put that in update bullet. So we'll check. So after we've shifted a little bit, we'll check, or actually, no, we'll check, we'll do a separate function. That way both bullet and enemy have moved for this turn. So we'll do, we'll call it, let's call it check collisions. Check collisions. And actually, we won't need a delta for that. Okay. So we need all of our enemies, we need our ship, and we need the bullet. We're going to check, we need to check both. Does our bullet hit the enemy? Does the enemy hit us? And also we need to check, does the bullet go off screen, or has the enemy gone off screen, either up or down, based on which way they're moving? Because right now we have, like, if I keep firing, and here we'll console log it so we can see it. So if I just keep firing, notice how the number of bullets in the array keeps going up and up and up and up and up. if we kept doing this for a long time, we'd eventually crash the browser because we'd have so many that we would just run out of memory. So we want to clean up after ourselves. Once the bullet has made it off screen, we don't need it anymore. So we'll delete it. And then similarly, the enemies are doing the same. Once they get down here, we don't need them either. So we'll clean them up as well. So let's do one at a time. So first we'll check as an enemy and a bullet collided. So let's go ahead, just like our hits, our points hit rect, let's make a, did I call it points hit? Yeah, I called it points hit. We'll call this rect hit rect. So we'll compare if we hit two rectangles. And MDM actually has a handy little tutorial or whatever for this, so you can grab the formula right here. And it's pretty similar to the point hit rect, with the difference being that we're comparing the left edge of one rectangle with the right edge of the other, and then vice versa. The left edge of one with the right of the other, to make sure that they cross over one another. So we'll do and then whenever I have two things that are basically the same thing, I just like to call them A and B to save some typing. And I'll just do find and replace. So place on all of those, place on those, and return or export default point rect hit rect. And then we're using with the actual words width and height instead of W and H. Okay. Oops. Didn't quite work out. Let's do this. Okay. And now let's also go ahead. Oh, change that. Whoops. Rect hit rect. Hit rect and hit rect. There we go. Okay, so we got that. And now let's go ahead, just to make our lives easier, in the bullet and the ship, we're going to go ahead and just store the X and Y. That way they're a full, complete rectangle already. And we don't have to deal with grabbing the image later on and doing that. And this also makes it easier if we wanted to add more types of enemies or something. Having it be complete means you complete each one for each enemy, and you don't have to worry about grabbing it later. Okay, so now let's go to here, and so we'll loop through each bullet. So for each bullet, and then we're gonna also loop through each enemy. And we're going to check if they hit. So if, and we'll say if not, so we will bounce out early. So we have some bullet and enemies. They have all the things to be treated as a full rect, so that's good. So if we make it down here, that means they hit. So if we hit, we're going to destroy the enemy, destroy the bullet, and get a score. So let's actually, it's easier, instead of trying to, so to destroy it, we need to remove it from the array. It's easier if you remove things when you're not in the array, though, when you're not looping over them. So what we'll do, instead of removing it here, we'll do destroyed equals true, enemies destroyed equals true. We'll just mark things destroyed, and then we'll clean up, delete all the destroyed out in a second. And then we'll do this stuff for plus equal, and we'll just say for enemy. Let's say we get 50 points in it. Points per enemy. Okay, and let's also then, we want to check then if we've already destroyed a bullet or enemy, bullet enemy. If we've already destroyed a bullet or enemy, we don't want to let it destroy multiple things. We're not doing multi-hit. So we'll just have the first one hit it. Okay, so if bullet's been destroyed, or the enemy's been destroyed, or they don't hit, we're not going to do anything till the return. And because this isn't one line anymore, I'm going to wrap it just to be obvious. So that's our bullet versus enemy. So now we'll do a loop over each of our enemies. And that's, yeah. So we could rearrange these and have just enemies and have bullets and the player in there, and then we'd only go over each enemy once. But the downside to that is we may not detect then that, well, actually no, because we can just check the bullets first. So let's actually do that. So we're going to flip things around. So actually, I didn't need to move that. They're the same. Just need to move this. Tap out. So this way we're only going through the list of enemies once, which is a little more efficient. So first we'll check all the bullets and make sure we haven't hit it. Otherwise, if the enemy hits us, so if not enemy got destroyed, so make sure we didn't hit it with a bullet. And let's hit direct ship enemy. And I think we put with and ship, right? Yep. Okay. So if we hit, we'll say the enemy is destroyed on hit, and then we'll take a damage. So lives minus. And here we'll check. So, well, actually we won't check here. We'll check later on though. If our lives get to 0, we die. And then, okay. And then we're going to check if finally if the enemy is off the screen. So if enemy, so off the screen in this case means its y would be greater than or equal to the height of the canvas. So we need to grab the canvas with context. Or we need to grab the canvas from the context, rather. Okay. And so if the enemy's y greater than canvas dot height greater than or equal to, then we destroy the enemy as well. So there's a couple ways it can get destroyed. Okay, and now finally we need to check each of the bullets. So we do still have to kind of go through both of them. We need to check if the bullet's height is, or let's see, if it's y. So for a bullet, it's off the top. So it would be if its y is less than or equal to negative bullet dot height. Actually, that's a little confusing just to think about. So if the bullet's y being 0 would mean that it's touching it. So height would mean it's fully off screen if we subtract height. So if this is less than or equal to 0, then bullet dot destroyed equals true. And now let's go ahead. We'll make a new function. We'll call it cleanup. And this will go through and so cleanup will just go through and delete all of anything marked destroyed. So enemies and bullets. This. Okay. So enemies dot sort or enemies. So here we'll actually just set the enemies array. Excuse me, to filter it out. So we'll just do enemies dot filter enemy dot destroy, or enemy dot not destroyed, because we only want to keep the stuff that's still good. And then similarly, bullet dot filter bullet dot destroyed. Okay, so I'll clean them up, and that way when we draw after the tick, they won't be there. And then finally, let's just check if this dot shift dot y is less than 0, or less than or equal to 0. Then we need the scene manager, change the scene to scenes dot game over. 3 dead. Nope. And so here it's complaining about awaiting. I don't really need to await here because I don't care. if it finishes or not at this point. So we'll just kind of ignore that squiggle. Or in a lot of IDs too, you can be like, this press for statement, and I'll put this little comment up here. That should go away. For whatever reason, it's up there. Yeah. Okay. So let's check first that our collisions are working. So give me one in the center. I don't want to die. Okay. So that's one. Okay. So I hit it and I got points. Yay. All right. And now let's hit us. 1, 2, 3, 4. I'm dead. So now there's a game over screen. We haven't put anything on it, but so that works. And now let's check. We'll console log our this.bullets and this.enemies, and we'll make sure that their numbers go back down. So like enemy will go up and down, and it looks like it is. Whoops. Okay, I'm going to fire 3 bullets, and bullets is empty again. So cool. So that looks good. So that's everything but power-ups now. So let's go ahead and add power-ups. So just like bullets and enemies, we'll do one that's just power-ups. Like that. Okay, and so just like enemies with the spawns, we'll do a power-up spawn rate. Let's say we maybe get one every 3 seconds, so that would mean it's 0.3 per second. And we'll say power-up variability. Power-up spawn variability. Oh, why did I do? Oh, right, because that's what. So let's see. So for power-ups, we could have them move down as well, like enemies, or we could have them just kind of appear and we have to move over to them. Let's just keep it simple and we'll kind of mimic enemies. So, pixels. So they'll have a speed gun. Actually, no, let's not do that. Let's do, so let's say we can get up to 1 per second. So we'll add these, we would add these two together. So we'll say that pop-up or power-ups are just going to kind of spawn on screen and we have to maneuver over to them just to do something a little different. Okay. So now let's do this. So this spawn power-up. Or actually, we don't need that. Okay, and we're going to track the last power-up. Okay, spawn power-up. Actually, let's go ahead and rearrange these so they're in the same order as this. Kind of like keeping them in the same order makes it easier to know where you're going to need to scroll to get to them. And then fire should be first. Okay, and spawn enemy, spawn power up we need to make. Okay, and background ship bullet enemy. Background ship, wherever it went, right there. Ship bullet enemy. Okay. Alright, so spawn power up. So for this, so we start out pretty much the same as with enemy and bullet. We'll do last power up. And now here we actually have 2 types of power ups. So we have health and oh wait, we didn't. Oh yes, we did. What did we call it? The other power up. Oh, it was a battery. That's right. Okay, and then so power up, and so here, oh, we didn't actually add, oh, right. So before we controlled spawn variability by just changing the Y. Here, since these don't move, we're going to change the spawn variability by playing with the time. So to do that, we're going to do spawn rate, and then we're going to do math.random times any spawn rate variability. So it'll be 33 seconds, or every 3 seconds minimum, but then we may get, if random was 1, we may get all the way up to 1 a second, or it'll be 1 every 3 seconds. So between 3 and 1 seconds per power up. Okay, now we'll make power up. Okay, so the X, so first we need to pick which type of power up we're doing, because we have 2. So let's actually, let's go make a constant up here for power up, and these are just going to be the names. So we'll have health, or rate of fire, we'll call it, because it's going to make us shoot faster. Right. Okay. So power up. Down. All right. So which power up? So we'll just do if math.random times 2, because we have 2 options. We're going to explore this. Equal 0. So we'll say if it's 0, it's going to be the health. Otherwise, it'll be the rate of fire. Okay, so if it's the health one, we're going to do type powerups.health. We're going to do an X. So we'll randomly position this somewhere on screen. And for X, it can be the whole screen, because we can move through the whole screen. So we'll just do math.random times canvas.width minus health.width, so it's fully on screen all the time. And because these are pixels and we don't want to deal with subpixels, we'll explore it. And then the Y, remember, we can only go halfway up, so we don't want it out of our reach. So we'll also restrict this to halfway up. So for this one, we're going to do random times canvas.height minus health.height. And then to make it, so canvas.height divided by 2. And then how it's written here, this would only ever put it in the top half, because it's going to be between 0 and half of canvas height. So we'll then add half of canvas height, so it's all the way outside of the random stuff, so it's always down in the lower half. And then to make a full rectangle for ease of life, we'll do width and height. And that should be that. And then the other one is pretty darn similar, except instead of measuring it by that, we'll be measuring it with battery. So we switch to battery. And then this switches to rate of fire. Okay, and then we'll just push this on to power up. Okay, so that creates the power up. And we don't need an update power up because we're not moving it. We will need to check the collision. So we'll go ahead, we'll add a collision for that. Power up. So power up. Dot for each power up. And the only thing we care if power up collides with is our shift. So if not, we don't need to worry about the deployed and the sieve statement because we can only get it once, so it wouldn't possibly be destroyed at this point. So if we don't hit it, we do that. And then, so if we did hit it, we need to check what the power-up type is. So the power-up type is powerups.health. Double check, we did call it type, right? Yep. So we'll do, so if it's health, if it's health, we're just going to give ourselves 1 life. And let's go ahead and put a maximum on their lives, because we don't want like 800 lives. I mean, you might, but it would look bad for the string. So let's say 6 is our maximum. So let's go down here. Oh, no. I'm looking for ship collision. Okay. So well, actually, we'll do ship.live plus 1. And then we could do an if statement to check if it's higher and yeah, to check if it's higher before we add it, or we can just min. So if we do go over the limit, we'll instead just stick to 20. Otherwise, we'll do, so this will be rate of fire. So for rate of fire, so we have a fixed rate of fire. So we're going to need to update this. So we'll just keep track. We'll say we'll have a Boolean for faster rate of fire. And then we'll also do rate of fire start. Or we'll call it faster rate of fire start. So we'll track when we got it so we can clear it out because we don't want faster rate for infinity. And we'll do a rate of fire duration. We'll say it lasts for 10, let's do 10 seconds because we'll have lots of chances to get it. So you can, each time if you get it and you already have it, we'll just reset the timer basically. And I just realized when we spawn power up, I don't think I spawned up. Yeah, power up spawn rate. That would have made it fast. Power spawn rate. There we go. Okay, back to check collisions. Okay, so here we'll do this dot faster rate of fire is true, and this dot faster rate of start equals heat dot now. And then, regardless what the power up type was, we'll mark it destroyed. Okay, and then let's go to cleanup. So we'll clean those up. Go to the list just like the other. Okay, and now to make this actually do something, our faster rate of fire, we need to go tweak the bit that controls how fast we can fire. So here, let's say we'll just have a hard-coded bullet faster rate of fire, and we'll use that if the value is true rate of fire. So we'll say we can fire 6 of them per second. We'll just double it. And then down here, we're just going to check faster rate of fire. So if we're using faster rate of fire, and we're going to use the bullet faster rate of fire constant. Otherwise, we're going to use the bullet rate of fire constant. And then down here, we'll just add a check if actually, we'll put it in cleanup. We'll put give a now if now plus this dot faster rate of fire start, now minus rather, greater than or equal to faster rate of fire duration. Let's call that faster rate of fire duration. Then we'll set this dot faster rate of fire false. And so if we hit it multiple times, this is going to keep resetting. So technically, if the power-ups come up fast enough, we grab them fast enough, we can have the faster rate of fire forever, but or we may not, and it should go away. So let's see what this is. Okay, the last spawn is not defined. That gave us, so when I click this one, it output here because we had that conflict catch, but if we go down into our stack, this is how it really was. spawn power up. Oh. Oh, actually, are we syntax here maybe? Yes. That helps putting a semicolon. That's not wrong. There we go. All right. So let's see. Oh, we didn't draw our power ups. So let's go down here. And actually, for power ups for type, let's also just go ahead and we'll tuck in the image in here. So health. That way we don't have to have another if statement to go track it. Battery. Okay. Now we'll do. So let's see. We want the ship to go on top, and actually, yeah, we'll have the image go on top. We want the ship to be on top, even though top, draw top power up. Okay, so keep them in the order. Draw power up. Power up. Power up for each power up. And because the image in here, we can just do power up dot image, power up dot x, power up dot y. Okay. Now, our rate might be a little fast, just a little. Well, actually, our hearts hit this too. So let's go ahead. We're going to shrink our hearts. We'll just shrink them in code, though. So when we draw the lives, we're actually going to add some additional parameters. So by default, we just specify the destination x and y. We can actually specify both the, we can actually specify both the source x and y width and height and the destination x, y width height. So we're going to do that. So we're going to do 0, 0. So this is source x and y. Then heart.width, heart.height. And then these are our destination x and y, which are still good. And then we're going to do, you know what, actually, we can just specify just the destination. I think we'll shrink it too. So we'll do heart width times 0.8 and heart height times 0.8 and times that by 0.8. And I did something wrong. Heart. There we go. Okay, so that looks a little better. All right, so now let's figure out what's going on with the R in machine of spawn rate. So spawn power up. Oh, you know what? I bet did we forget to update? Yeah, we never actually set last power up. So last power up is always never. So it's always time to spawn a new power up. So let's just set that now. We copied the code from. No, oh, yeah, we only copied. There we go. Okay. So still a little fast. But let's see. So is our faster rate of fire working? So fire 1,000. Yeah, I think a battery spawned right on top of us and got it instantly. So let's go crank that quite a bit down. So let's say maybe every 10 seconds. And instead of doing decimals, we can just use math too, so if it's feasible. And then we'll say we could potentially double that. So we could potentially do, if we add these together, that'd be 2/10, so that'd be 2/5. Or sorry, it'd be 2/10 with 1/5, so we could get one every 5 seconds up to. So okay, and we're getting a power up right away because our last power up was set to 0. So let's go ahead. We're going to do date.now. So we'll act like we just add a power up so we don't get one immediately. Okay, so let's see if we get one. Okay, so there's one. Let's put our power ups on top of the enemy so we can see them better. Change our drawing order. We'll rearrange these just because I like to keep them in order. All right, so let's see. So I took some damage. Grab this pallet. Okay, so now I'm firing faster, which is good. Got some health back. Got some more health. More health. Faster rate of fire again. Let's actually. Okay, so that's how fast we're firing now. Can't really tell if faster rate of fire works. Let's go. We'll speed up the faster rate to a really big number just to make sure it's working. Okay, so there's our rate currently. Wait till we can get a battery. Okay, so it's not really working. So let's go take a peek at what's going on. Let's get down here. Okay, so here's where we swap it out. So faster rate of fire. So let's console log faster rate of fire. Let's console log this, just so we can see what we're getting. Okay, so we're at false in 3. That's the battery. Battery, there we go. Okay, so it's still false. So that means we probably didn't set it right. So we may have named the variable wrong. We set it as something. Faster rate of fire. Alright, let's go see. We may have just set it wrong. Let's check collision. Faster rate of fire is true. Power up. Okay. Did we actually forget to change the power up type maybe? Power up rate of fire. Interesting. Okay. Log. Oh, or it could be that our bit that sets the stack is wrong. Or it could be get it and then it turns up off right away, so that can clean up. Okay, so if now minus this dot faster rate of fire start to do set is greater than or equal to faster duration. So this should be how long we have it, and this will be, oh, you know what, this is in milliseconds, and I think we did this in seconds. Yep, so let's do this in milliseconds. That's probably the problem. We were getting it, but we only had it for 10 milliseconds, which is no time at all. Okay, there we go. All right, so that's definitely working now. Cool. Let's go put it back to a more reasonable number. And let's get rid of these console logs. Okay, so now we're firing. Battery. All right, there we go. So now we can notice what we see a difference. Okay, and let's also, we'll go, let's give ourselves points when we get a power up. So points per power up. We'll give ourselves 500 per power up. And then let's also make it so since power ups don't move, let's make them despawn. We'll take lifespan maybe. So we'll say it lasts for 5 seconds. So if you don't get it in 5 seconds, so we're going to do 5,000 milliseconds. If you don't get it in 5 seconds, then it disappears. So let's go in here. We'll put spawned. So when it spawned, and we'll set that to now. And then we'll go to clean. We'll do it in cleanup, where we clean up. So we'll check now to destroy one. We'll check either if it's destroyed or now minus power up, singular, power up dot spawn greater than or equal to power up lifespan, and we'll also remove it. Okay, so now wait for power up to show up. Okay, 1, 2, 3, 4, 5 ish. Disappear. Go away. Alright, so that's not quite working. So let's see. So first make sure I don't have a syntax error. Nope. Okay, so now minus power up dot spawn. So that should be how many milliseconds it exists. And then this is if that number of milliseconds is greater than or equal to this number, 5,000. Should disappear. 1,000, 2,000, 3, 1,000, 4, 1,000, 5, 1,000. Okay, so let's go and clean up then. I'm going to console log to route this. Keep returning that. And then oh, you know what? It's because this is the opposite. These are the ones we want to keep, but this is what we want to destroy. So we want to actually say and less than or equal to. Waiting for power to appear. Alright, did we just, nope, I've got 1, 2, 3, 4. There we go. So now you got to hustle to get over between. So that's a little more exciting than just camping one place and then waiting for it. Okay. And so I will point out one thing. We're not going to worry about it today. But notice, so like, see the shape of my ship? See how I hit it? Because we're only doing rectangular collision. You can actually do like fancier collision, which we'll do someday, where you actually look at like the actual pixels that are filled in and you see if you've actually connected with it directly or not, which gives you nicer things. So what we're basically doing is called hitbox collision, and then you also have, in 3D you call it mesh. I don't know if there's a special term for when it's in 2D, but you basically do mesh collision. You check if the shape's actually hitting stuff. Oh, and we didn't add the thing to give ourselves points for power up. Power up. Draw power up. No, draw collision. And let's go ahead and split collisions up into functions. Cut that. So we'll do this dot check power up collisions. This dot check enemy collisions. This dot check bullet collisions. I don't remember if there's another one or not. Check power up collisions. Check enemy collisions. Nope, there wasn't. Check bullet collisions. Okay, and then we just need to copy this. Cut it. Cut the things off. And we'll just delete anything that turns gray. All right. There we go. Check this all works. Okay, seems to be working. Okay. And now, last but not least, let's go ahead and implement the game over scene. So we'll go, we already made the game over scene. So game over is so close to start screen, so I'm just going to kind of copy start screen for now. And then, yeah, so we'll just copy the gut to start screen. then this is going to be play again button. And refactor. Okay. And calling about duplicate here. This play again button. And we're going to load the play again button. Play again. Okay. List draw play again. Okay. And yeah, it's complaining about some duplication, but that's duplication by coincidence. It just happens to be the same code, and I don't worry about that when we're thinking about being dry. Don't repeat yourself. You only want to really be dry if it's duplication that's really performing the same thing. In this case, it's just we happen to be doing things that are similar, but they're not really the same code. And if one changed, that doesn't necessarily mean the other changes. So that's like that's duplicate by coincidence. And so I don't try to make those dry. Okay, I'm gonna give myself one life to start with, just so I can get the game over faster. Okay, the game overloads. We want to show our points here. So first we need some way to get the points out of game scene over here. So like we did yesterday, we'll make a data manager. And just like all of our other managers, this one's going to be a singleton. Yep. This one's just going to have a generic set of data, and we'll just do set, and it will be the key and the value. And we'll just do this set of data, key equals value, and we'll have a get introduce data. Okay. So it just kind of holds arbitrary data, and so then when we die, so here, before we change scene, let's do data manager dot set score, and let's go ahead and make a constant for that. So export data keys score. Use data keys score, and we'll set that to this score. And we can import that. And now we'll run game over. We can read that in. So we'll do this draw score. Score data manager dot get data key dot score. Okay, and then we'll do fill style. We'll just do white text. We won't do a stroke, so we don't combine with. The font size, let's shrink it. Let's go maybe 48 pixels. Maybe. Helvetica, serif, context.text baseline. So let's align this to the middle, and we're going to snap this on the middle of the screen. And we'll do text line center. Context.text, final score. Okay, score. Okay, and then so we're going to smack this right on the middle of everything. So context.canvas.width divided by 2, context.canvas.height divided by 2. Okay, that should be it. All right, so let's get a score bigger than 0 real quick. Should be good enough. Let's die. Final score 100. All right, so let's shove it up a little because it's a little too down. So we'll do. Oops, and I have to do this. Oh no, I didn't. So we'll just say minus 100. maybe. Let's see what that looks like. All right. Or not. Not too much. Let's split the difference and go 50. All right, kill me. All right, that looks good. Now if we play again, so there's a bit of an issue with play again. So if I play again, notice my score was still 50, and that's because I initialized all my values up here. Really, we need to initialize stuff when we enter, so it resets. So basically, all of everything except ship, which is already in here, we want to initialize the things. And so when I need to set a bunch of stuff to the same thing, what I actually like to do is use objects that are signed, and then I can just kind of put them in as one object. So we'll say score starts at 0. Images we don't actually need to reload because they'll be the same. So we'll actually go make it so we don't load those if we already have them. Ship, bullets should be an empty array. Enemies should be an empty array. Power-ups should be an empty array. Classified equals 0. Left on equals 0. Last power-up equals now. So we don't get one right away. Faster rate of fire is false, and faster rate of fire start is 0. And what is funky about? No, let's get rid of that. Something silly. Oh, is there something there? Oh, I just left the user sign. There we go. And okay, so that will set us up. And then I don't like to define defaults twice because that can get confusing if you're like, I changed the default, but it doesn't actually change. So get rid of the initialization here. Okay, and then we'll go into load images, and we'll check if this.images already has, if just this.images has anything, then we'll return, because we've already loaded them once, we don't need to load them again. So now let's see. So all right, so I have 100 score. I die. Find the score 100. Hit play. All right, we're back to good. So now let's put our score, our start health back to 4, and then let's go all the way back to index and start at the actual start string now. And I do believe we're done. So we start. We can play for a bit. Shoot. All right. And remember, and just like how I showed you that the power-ups hit too soon, we technically collide with the enemies like that too, so we want to be careful of that. And obviously, that's not great for a final game, but I think for what we've built in 3.5 hours, pretty good. We'll call it good. We'll cover more accurate collisions in another project in the future. Okay. All right. So let's let myself get murdered now. I got 850. Okay. Now I hit play again. All right. And health reset, score reset. Looks like we're good. All right. So I think we've done it. Nice, simple little shooter game. You can, if you want to. So I'll go ahead. And I'll push this code up. So I'll make a new repo. And this is space shooter. We need a string. And if you want to download this and play with it, I highly encourage you to. Playing with code is a good way to, that someone else wrote is a good way to get experience as well. So, and now, since we cloned a different repo, I need to do git remove origin to get that origin off. And I need to add this new origin. And then I'm going to do git add dot. Now everything should be green. And then git commit. Okay, and then I there's the code. So if you want to grab that, feel free. I also, yesterday, updated the website a bit, and so now all the projects will be listed here. So if you want to track down a project, you can go here. So I'll get, actually, let me actually shoot her in there right now. Main website, and we'll do project page. I'm going to copy this card, and we'll go make that big shooter. I don't actually have the URL because I'll have to end the stream. So we'll do that in just a second. But I'll get that up there. Yeah, so thanks for joining, everyone. Hope you learned a little bit, had a little fun. You know, if you want to check out my stream, still trying to work out what a good consistent schedule is. We'll get one, just still trying to figure it out. But for now, if you follow and turn on notifications, you'll get a ping when I start streaming, so you can come tune in. I also try to announce on Twitter before I'm going to stream. Usually I do it as early as I know I'm going to stream, and then I do it a little bit before the stream actually starts. So if you follow on Twitter, you can hit that way. You can check out old videos on YouTube, or recent streams you can check on Twitch too. If you have any ideas, or you want to play with something and you have any code questions, or you just have any code questions at all, you can hit me up at Discord. All of that is in the channel. You can hit about, and you can find Discord and Twitter and YouTube links on there. And you can also find it all on the main site. And yeah, so thanks everyone. See you guys next time.